Good morning. Hope everybody's doing well. Full of donuts, maybe. Good. So yesterday happened. So it's funny, you know it's going to be a weird day when the phrase act of God keeps popping up in casual conversations. But semi-seriously, I want to thank everybody who made yesterday possible. And I mentioned a long list of names yesterday, so I don't want to go through all that again, but I want to take a moment to give a special shout out to the Portland Center Stage team to give you kind of an idea of what they did to make this happen. So 7:30 yesterday morning, we had no idea other than we had an idea of what we thought we wanted to do. So they started off by back-channeling a venue acquisition. So they knew folks that knew folks over there. Once we had an idea and I got on the phone and we sort of made things start to happen, not only did we're prepared to go over there, they packed up the AV equipment, food, screens, and pretty much everything you'd need to run an actual production theater show, and took that to the other venue. Yeah, please. Although they didn't take the set. I mean, come on, really? Thought we were professionals. But to underscore, we were over there, and again, it's not that I don't appreciate everything that Pure Space did for us, but I want everybody to understand that that was not Pure Space staff running the show. That was Portland Center Stage running the show in someone else's house. That's amazing. And I know this is cliche, but that epitomizes the phrase, the show must go on. So just again, I'm proud of everybody that was involved yesterday, from our staff, the volunteers, the speakers, of course. Awesome, all of you for being so accommodating and understanding. And of course our sponsors. And it's unfortunate because we have the sponsor tables here. And please, I encourage everybody to go out, see our platinum sponsors today, pick up some of the gold and silver sponsor swag. They really help us and they make this event possible. But again, not only did we pull off what most people would claim to be impossible, but we did it on schedule. That's mind-blowing. So that's it. Back to business. Very excited to be back here in our favorite venue. Again, we have Blue Star Donuts in the lobby and in the mezzanine. We have Nosa Familia Coffee coming back again today. They should be here any moment. See, this afternoon, some of you may not know, I've actually written a book. It's the graphite book. Oddly enough, we actually did a signing last year of the early release copy. And it was slightly overdue. But final release is out now. We have a stack. I'm actually going to be doing signed copies for charity. So if you're interested, catch us at the afternoon break in the lobby. It should be around 3:40 p.m. Books will be $40. We can take cash or we can take... Actually, I don't know if I have a square thing. So ideally you have cash. If you don't, we'll try to figure something out. And I was thinking about signing a hashtag Monitorama Eclipse, but I don't know if my hand can handle that. So, all the announcements out of the way. I am very excited to bring our first speaker to the stage this morning. This is their first time speaking at Monitorama. And this particular person needs no introduction. Just kidding. So the speaker is the founder of the Hangops community, which I'm sure many of you are familiar with, and he's just a generally awesome person on Twitter and in real life. So I am very pleased to introduce @Solars, also known as Brandon Burton.
Hello, hello. All right, hi Monitorama. Quick intro, as Jason said, I'm Brandon @Solars, and I like GIFs, so I thought I would share a couple that I like with you. Recently I've been into what are called doodle GIFs, where you kind of take something and add a little eyeballs and other fun things. Another good one. All right. Oh, okay. So some of you may know I work at Travis CI. I work on a team that we call Build Infrastructure Engineering. At a high level, this represents kind of job execution, build logs, and infrastructure operations as sort of our areas of responsibility. And to set a little context for what I want to share today, I'm specifically going to be talking about our build logs and what that means. So a little bit of a history on Travis's build logs is that when Travis was becoming a thing and starting to become a distributed system, we designed the build log system to deal with small chunks of ANSI text that we call log parts. And so essentially while your build is running, every few bytes or every half second, we're taking the text that's coming back from the SSH connections running your job, putting that in a RabbitMQ as what we call a log part, and then that log part is then being processed into Postgres and eventually stored into S3. And so this design has scaled fairly well since it was implemented like 4 years ago, in part because it allows us to transport things simply, right? It's just a few bytes of text, and then we can sort of outsource a lot of the scalability around storage and serving it to S3. But because some of those original design decisions, what that means is that the build logs, they're not indexed, it's not built in a way that they're searchable. And ultimately what that then means is they aren't potentially available for us to use for different kinds of telemetry. So then that kind of leads into, right, there's a challenge, right? We've built the CI system and it's become, a fairly large CI system. We're executing millions of jobs a week. And by design, a CI system is one that generates a constant stream of errors. But the majority of these errors aren't relevant to us that are building and running Travis, right? They're relevant to a developer or a team or maybe a larger open source project. But some of them can be. A good example of this is shortly after I started, I don't know, I've been at Travis a couple of months, so it was like, around Q3 2015. I was working and I live in LA, I'm on the West Coast. I'm one of the couple West Coast people in Travis. Most are Eastern or time zone or in Europe. And one of our support folks was like, hey, we started getting some tickets that Git clones are failing in our Mac environment. And our Mac environment is kind of interesting because it's more of this like enterprise stack. It's privately hosted. We're running vSphere and vCenter with Apple hardware and SAN storage and dedicated Cisco firewalls and pfSense and VMs for natting for things. And so there's, it's this more kind of almost like private cloud, if you will, type of environment. And so, I being the only person in build infrastructure around at the time, because it was maybe 3 or 4 p.m., I start looking and, I'm looking at some of the build logs and I'm saying, okay, Git clones are failing. And so then I'm like, well, maybe it's some kind of a network issue. So I, check on the Ciscos, check on bandwidth, check on pfSense, CPU, kind of all these things. And no, everything on the network level seems fine. And then, so I'm going back, I'm staring at these build logs, which if any of you have looked at a build log, it's a lot of text. And then finally I noticed it's, could not clone, could not resolve github.com. And then I'm like, oh, okay, so all right, well, is GitHub having DNS trouble? No, everything's fine. GitHub says they're good, our Slack integration with status page hasn't alerted us to anything. So I'm like, okay, I'm not as familiar with this environment. So I'm like, well, what DNS servers are we using, right? We should probably be using, local resolvers forwarding to 8.8.8 or whatever. And we were using the upstream DNS servers provided by the hosting provider that specifically does this Mac stuff for us. So ultimately, it was a DNS issue. Their primary DNS server was having some kind of an issue. And so that was ultimately what manifested itself originally as users saying, hey, our jobs are failing because we can't clone from GitHub. And it took a while to suss it out, right? And similar to what Bridget alluded to yesterday, right, is like once you've been burned by the stove, you always check that. And so for me, having run a lot of network edge NAT infrastructure, that was the first place I looked. So this is one good manifestation of say if we were able to take the fire hose of this build log data, right, like extracting something like errors from the git command out of it right, we could add some kind of a search or something, right, that could look for this in the future and specifically be like, oh, git clone failed and it was a resolution issue that would let us hone in on that more. Some of the other challenges, right, third-party service outages, pretty much any time PyPy, Ruby Gems, or Launchpad, which is notably not highly available, those PPAs go down. We get a lot of, hey, my builds are broken, what's going on, right? And similarly, there generally is data that points towards that in the build log, but it's typically masked, it's like apt get update fails with a 404 or some kind of other error, or Ruby Gems is failing on bundler update, but those kind of failures aren't as apparent to users who maybe haven't dealt with a Ruby Gem outage before or something. They just see like the build failed, it wasn't in my tests, what's going on? And sometimes it can just be stuff changed somewhere, right? Left pad, when that was briefly removed, was a good example, because that was a lot of like Twitter and support tickets. People are like, hey, what's going on? So there are these potentially useful sources of data in these build logs. So, right, okay, we have build logs, we're generating them, it's text, right? Surely it's easy, right? Make that indexable, make it alertable, make these errors discoverable. But, okay, well, what does that mean? What does it mean to take that log data? What does it mean to index it, make it searchable? And so this is a conversation that in part we've been having as long as I've been at Travis, in terms of, do we want to take this thing that we intentionally built to be simple and scalable, and mostly we see as noise, if you will, for us, and do something with it. So, right, that discussion, well, you start with, okay, well, which tool, right? Just stand up some Elk, just stand up some Graylog 2, something like that. Well, then that leads you to running Elasticsearch, which, most ops people are like, please no. And Elasticsearch is a great tool in some ways, but it has had a rough history operationally in some ways. And so then that's like, well, do we build? Do we buy? Right? What kind of ownership are we taking on, just by virtue of the fact that most of the common tools that are available if we want to build something do rely on Elasticsearch, and so you can end up with these big Elasticsearch clusters. And so it's even a question of, well, what if we bought Elasticsearch instance, Compose.io or Amazon or someone else who sort of they at least you can pay them for the operational overhead. One of the ways that we've talked about approaching this is our .org builds. So those of you who aren't familiar with Travis, there's travisci.com, which works for private GitHub repositories, and then travisci.org, which works for public GitHub repositories. And they're separate infrastructures, separate. You tie them into your GitHub account separately, different subscriptions and things. And so Travis has provided this open source service for any public repository on GitHub for a long time, and so a lot of people use it. So we do have this large amount of data that is being generated that is also public by default. So it makes it a little easier to potentially start undertaking an experiment to say, okay, well, what if we stood up one of these things, and then we could try with 24 hours, right? Potentially grow that to 3 days, to 7 days. But even just like the process of sitting down and figuring out how to, build an initial MVP of something and then start populating that requires a certain amount of time and investment, and trying to figure out, well, what's the scope and what would that mean, and then how do we measure what it would cost to make it bigger. That gets even more complicated if we look at the travisci.com build logs, right? Because these are private by default. There's potential privacy concerns around that. Customers who are using us for their private builds, just by sort of default are inherently, more sensitive in a way, understandably, about like, okay, well, what are my build logs? And so, not every user, public or private, may necessarily be conscious of the current state of how the build logs are stored and whether they're indexable or not. But, if we were to make a change like that, we would probably want to talk about it and blog about it, and, and say, hey, like we are making this more easily like accessible and searchable, that at the very least would potentially raise questions. And no matter how many FAQs you write, how much documentation, there's still a certain amount of people that they just email you or they reach out, or like the way it was written wasn't quite answering the way that they had the question. And so even just implementing this could potentially mean an increase in support load for at least a brief period of time, as we have to answer new questions. And right then, ultimately, there becomes a question for us of, okay, if we make this searchable, does that actually constitute an increased threat to our users, right? Even if it's something that we build internally, we decide to operate all the pieces of it ourselves, we run our own Elasticsearch clusters, everything is locked down in the same way that the rest of our infrastructure is. We use the same access controls that we use for other internal resources, right? Does it potentially increase the threat scope for users if someone were to get into that and then potentially search it, right? Versus like if someone were to somehow get into those S3 buckets where things are stored, they would have to start extracting it, and they would have to build something themselves to index it and make it searchable and try to look for something to harvest. So it becomes a matter of, okay, it might be more convenient for us, but then also what potential new threat does it present, right? And so these are some of the questions that I think aren't as obvious on the surface when you think, okay, well, there's a stream of text and I want to turn it into something that's indexed. We've been finding ourselves playing out. And so again, I come back to this, like, it's easy, right? Because I feel like it's kind of easy to say that, and as technologists. And so then, right, ultimately, we potentially say we do build this, and we say, okay, we can afford to do it for 24 or 48 hours, maybe up to 7 days, just to kind of keep a cap on costs, and also figure out utility. I believe it was the talk from Slack on Monday. They said, we do 2 weeks, and we found, or 18 days maybe, but something like that, and we found that to be generally enough, which I thought was cool to hear, and it's nice to validate, because I feel like even in previous jobs I've had where, it's like we want to log stash all the things and elk all the things. I've seen some of those efforts almost like get stalled before they even get it, because it's like, well, how can we afford to do everything and store it forever, and how would we architect that, and how many disks, and you get caught up in the planning phase, and it's like, because for some reason that is sometimes, I think, inherently as engineers, that's where we want to go. We want to build the thing. It's the penultimate, right? You get the same thing with metrics. It's like, we'll graph all the things, right? If it moves, graph it, right? So those are some things, and they are pithy, and there is some inherent truth to them. But then, there's still sometimes reality sets in, and that can be where things get a little more frustrating. It's like, okay, well, can we actually afford to do that, or what does it mean to scale that? And then, an interesting aspect for us around, potentially enabling this is, okay, we'll say we build it internally. Well, then, theoretically, users might want that. So what would it mean to make this a feature? What would that mean in terms of added scope for security, additional authorization? If we, use like something that's more off the shelf, would we have to build something to sit between it and our website and our API to deal with the way we authenticate our customers as users versus how we potentially authenticate ourselves as a single group? And that adds additional operations costs, and then support costs and infrastructure. And in our case, it also then leans into enterprise, right? We have this Travis Enterprise product. It's installed on site. What would it mean to say to customers, hey, this new feature then requires that you potentially need to stand up your own Elasticsearch and your own, Graylog 2 or whatever we chose, and then, what additional documentation, support resources would we have to give to a customer or to customers to enable them to use it? And so, where that leaves us then is so where we are right now. In a lot of ways, we are still in the discussion phase. These discussions have been happening over time. Often, new people join, and it comes up. And in a lot of ways, we have not. It hasn't been the biggest priority, right? Because there are potentially like these sources of telemetry, but when you look at it, we think, okay, relative to the fire hose of data, it might be 5%, 10% useful, and other features or infrastructure stabilization, things like that, have become a priority. But in the meantime, right, we have tried to say, okay, like, we have incidents where part of the retrospective was, hey, it'd be really cool if we just could search on that in the same way that we are able to search on the logs that our application generates, right? So we have various backend services and our API and all these things, and those logs we do send into Papertrail, and we do, have things to turn those into metrics and searches and alerts, but, right, that's a much more sort of targeted, controlled way in which we are deciding what to log and what to turn into metrics. as opposed to, right, the seemingly potentially similar problem of build logs, but which is actually much larger because users can theoretically do anything up to the limits that we put on log lines and log size, and so we have much less ability to control and influence that, and potentially have to filter that. And so what we have done though is in particular we've tried to add a lot of metrics. We look at things like we have this back-end service called the worker, which is responsible for it takes your job, it says give me a VM, give me a container, whatever, it runs the job. Each time that job finishes, it updates the state. So we generate a metric and we look at, over time, okay, well, what percentage of jobs are erroring? What percentage of jobs are failing? What percentage of jobs were canceled? How many finished successfully? And we can look at those as trends and, set thresholds and say if there's a big spike in error jobs, well, that could be a sign that maybe, there's a routing issue between, our stuff in Amazon and Fastly, or RubyGems is having an issue, or PyPy, or NPM, or whatever. And so, we've tried to sort of figure out, okay, how can we at least, give us metrics and alerts and things that sort of try to give us a little bit more of an aggregate picture, and then, try to look for sort of spikes, anomalies, things like that. And we definitely think we've had some good success in that, and just sort of trying to add metrics around a little bit more of a view of the system, and we continue to look for those and try to figure out what else we can do. So with that, I want to say thanks and kind of open it up for questions. Yes?
What do you do if Elasticsearch goes down during the build process?
So the question was, what do you do if Elasticsearch goes down in the build process? So at this point, we haven't built anything that uses Elasticsearch.
Well, I guess what would be your plan in that kind of architecture? Do you just accept that the build is okay or fail whatever and then move on? Dead letter queue?
Well, so if we were to build something where our build logs were also being ingested to something that maybe was stored in Elasticsearch, it wouldn't be part of the critical path. The way that our build logs are done right now is that each of these log parts, as I mentioned, which is a chunk of ANSI text, is put into RabbitMQ, and then there's a pipeline of other backend Ruby services that take that out of RabbitMQ, put it into Postgres. Eventually, we aggregate and archive it off to S3, and so somewhere in that phase, probably like during aggregation, we would emit that to the into like a forwarder or something that would then send it into a system to make it indexable. Yeah. Yes?
How do you make money?
How do we make money? Okay, so builds for private repositories on GitHub are paid, and we charge based on the number of concurrent builds. So like 1, 3, 5, 10, 15, etc. And then on the open source, but the public side, any public repository, there is a limit of 5 concurrent builds for free as part of that.
And is it not too expensive?
Is it expensive? Yes, it is. We spend a lot on infrastructure, which is interesting too in and of itself because relative to what we spend on infrastructure, we have a fairly small set of steady state services, and the majority of those we actually run on top of Heroku, which is a whole interesting subtopic on how Heroku has let us get by with maybe less traditional ops or DevOps-y type, people focusing on that. But when you look at some of our EC2 and GCE bills, you think, wow, that's a lot of servers, and it is a lot, but most of them live for 10, 15, 20 minutes. So there's a high turnover rate. Yes?
You mentioned some issues with various package repositories like IPI. Have you looked at doing like internal caching mirrors to avoid these kinds of issues?
Yeah, so the question was, since we do often see issues where a package mirror for some language has instability, and have we looked at looking at caches or mirrors? It is something that, yeah, we've definitely talked about it. It's something that I've even talked about and we look at. But again, similar to the build logs, it becomes a matter of what's the overhead, what's the operational cost and additional, right? VMs that live with potentially large disks, maybe a lot of RAM if we want to try to, serve most things out of something like Varnish. And then what is the operational overhead, right? Especially if we say try to run our own mirrors of things, because for some of these tools, there are some pretty good tools to let you mirror it. What additional maintenance overhead does each mirror bring, right? Potentially there's scripts that run, on the hour or the day, and well, what if that script breaks? Where does it send an error? What do we do about that? And with a lot of these things, it does come down to like, what is the operational overhead relative to the impact? And the reality is the bigger we grow, the more these things like the value versus opportunity cost of spending time with support and with investigating when there are issues, it starts to get potentially more and more valuable to actually take on the ownership of building and running these kind of things ourselves. And the space is also maturing. Artifactory is an interesting one. I know some of you may follow John Vincent Lucis on Twitter, and he's been in love with it for a long time. And it's definitely got interested in by proxy because they seem pretty quick on doing that. It's like, okay, well, there's a Docker registry, and now we can mirror that, and like they're constantly adding. And so something like that might also be an option of like, okay, what if we could just buy something and run it? And in general, Travis actually takes an approach of we buy a lot, kind of starting with Heroku, and then on top of that, looking at things that have a good Heroku add-on experience, whether it be for Postgres or Redis or RabbitMQ, or we use Librato for metrics and Papertrail for our logging, and we do use some Pingdom, so we're a pretty big SolarWinds customer now, which is interesting because a few years ago I ran like Orion and IP Monitor, very different type of SolarWinds product. But yeah, I suppose that answers your question and more. Anyone else? Okay, cool. Well, thank you very much.
All right, thank you, Brandon. I'm glad to be back in cold, foggy Portland. I hope you are too. Yeah, who's clapping? Cool, I'll talk to you later. All right, our next speaker is Amy Wen.
Let's hope this gets connected. Okay, great. Hi everyone, I'm Amy. Today I'm really excited to talk to you all about UX design and education for effective monitoring tools. So to start with, I wanted to tell you all what we're going to talk about today, which first I'll talk about who I am, what my company does, and our scale, so you have a sense of what kinds of work we do. Then I'll talk about why we should care about this topic, and then I'm going to talk about some principles that I've discovered are pretty important for us on how we design our tools. So that's going to be about how we share what we know and how we design what our users want, which is not really what we want all the time. And then someone yesterday said that recaps are good, so we're going to do that. So first, let's start with the background. Again, I'm Amy. I joined Pinterest in 2015, and I'm now on the visibility team. This is a picture of me when I started. Some of the things that we worked on over the past year or so include doing network tracing. We built our own custom tracer, and then we moved to Zipkin. We've done some D3 data visualization, so for example, like service dependency graphs. Then we wrote a Redis cache for OpenTSDB data, and then we did like all of the documentation in the world. And so those are all things that I would love to talk to you all about after this talk. And you can find me on the internet and Twitter and my homepage. And I think I have the greatest Pinterest account in the world, so I recommend that you check it out. So about Pinterest. Pinterest, if you haven't heard of it, is the world's first visual discovery engine. We help people discover and do what they love. Some of our stats are we have 175 million monthly active users. We have 100 billion pins, 2 billion boards, 2 billion searches every month, 150,000 requests served per second. And those are all these numbers that I just got from our PR sheet, and I wasn't really excited about it, but I think the numbers that are more exciting are our monitoring numbers. So first of all, we use Graphite, OpenTSDB, Kafka, Storm, Spark, ELK, Sumo Logic, Zipkin, and those are all really great tools. I think I missed a couple, but that's the space that I had. We log about 100 terabytes per day. We have 2.5 million metrics ingested per second, and the number I think is most important is that we have 400 engineers, and that's exciting to me because I like to think of engineers as customers. So that's the scale that we're operating at. So on Monday, Megan said that her team at Slack they'll do custom Grafana plugins, and we had considered that, but actually at Pinterest we built our own internal tool for viewing graphs, exploring graphs. Sorry, I feel like the floor is shaking, and building alerts. So I'll be talking through all of these different tools and how we designed them throughout this talk, so I wanted to get you familiar with them. So now that we've talked about our background, let's talk about why we should care about user experience. Some of you might be thinking, on call, I'm awake all the time, the floor might literally be on fire beneath me. There's so much going on in monitoring that is not user experience, so why should I care about this? If I'm on a team where we serve our users and there are other engineers, we don't have to make a profit, we don't have any revenue or growth goals. If our tools suck, people, that's all they have. So why does it matter? And to that I would say, have you seen Graphite? And have you seen OpenTSDB? And I just really want this thing really bothered me when I made this slide. I don't know why the legend came back around to the other side. I think that's the most confusing behavior ever. You can't even interact with the graph. All of this is terrible. And I think you all know that because I don't know anyone who actually uses the standard OpenTSDB interface. And so shout out to Monitorama. I'm really hoping I get paid for this because I just went and took a screenshot of the sponsors. So I'm hoping I get paid to do this. But as you can see, there's a ton of people who are working on this and hoping to make money because they care about the user experience of their tools. And that's why we're here. Because there's so many companies that will build these things. But as many people said, I'm not Brian. I don't have an enterprise tool. I can't afford all of these things. And so that's why we have to build our own tools. And so I want to formalize that more into 3 really big reasons I think this is important. So the first reason would be that it helps people prevent misunderstandings. Not everyone is or should have to be an expert at interpreting monitoring data. And I would say that at a product company like Pinterest, everyone is there for a different reason, whether that's because they know how to do they know how to do monetization, they know how to do internationalization, SEO. There's so many different skills, and not all those people have to know how to do monitoring. And if they do, you've probably accidentally built a DevOps company, and maybe you should rethink your priorities. But the point is that you should be teaching people how to use your tools. The next one is developer velocity. We want to help people reach conclusions faster. And as we've seen throughout this conference, people want to wake up at 3 a.m., find the problem immediately, and then go back to sleep. You don't want your developers spending 30 minutes trying to figure out how to use your tools, when ideally, if the user experience of your tools is good, then they will just figure it out immediately without your help. And the last is data democracy. At Pinterest, at Pinterest at least, we want all of our engineers, not only the SREs, to use our tools. And so whether that's our internationalization team wants to know which countries are having bad latency, or whether the monetization team wants to know if there's a specific where their problems are, we don't know what those questions are. I don't know what our data represents, and so we want to make it so that anyone can use our data without our guidance. And I think this ties into one of my favorite ideas in, software engineering, which is that the fastest way to become a 10x engineer is to help 10 other engineers do their jobs better. There's so many different ways to be a 10x engineer, and maybe that can be being an extreme coder or something. But at least for us, I think this is one really easy pathway to moving our company forward. I'm not really sure who said it, so that's why I'm attributing it to Michael Scott. So this is the, kind of short way of saying all the things I just said. We want people to prevent misunderstandings. We want to prevent misunderstandings. We want people to move fast. We want them to do it on their own. But I hate buzzwords. I was like, why am I writing all these really long words on the screen? No one's going to read that, whatever. So what I really want you to take away from this it's really boring, is that you should help people work correctly, quickly, and independently. And so that's the kind of, I guess, guiding principles that we'll be using for the rest of this talk. And so next, I want to talk about your situation, because I realize not everybody has their own internal tools built. I know a lot of us use vendors, and a lot of the vendors that we've seen are pretty great. And so I want to talk about why this should matter, even if you're not building your own tools. And so there's a series of priorities I think you should all think about before you even move on to your tools. So first would be your team. If your team is rude, or if they make people feel incompetent, or their questions weren't answered, that's a bad user experience for how you interact with your team. And so that's something you gotta think about. Thank you, I appreciate that. And then next after is your documentation, because again, you do want people to do these things on their own. So if your documentation is outdated, or if it doesn't have the right information on it, those are all things that you can control. And then finally, there's the tools, which is what I'll be talking about here. And then I realized that I needed a fourth triangle, because that's the format of this triangle thing. So I'll tell you that probably self-actualization is like paying for your own vendors or something. I'm not going to talk about that. I just wanted to make a cool triangle. And so today we'll be talking about tools, and then but I really want you all to know that there's things on all of our teams that you can control. Whether you have their extreme bash scripts, whether you have these programs that people run, there's a user experience there. It's about your team, your documentation, and everything. And so the tools are more fun to talk about, but I hope this shows you that everyone can talk about user experience. And so now I want to talk about how we all as monitoring experts can share what we know in an easier way. So the first one would be to think about education and intuition. It's really easier for us to get nerd sniped and talk way too much about monitoring, but most people don't care. If it's 3 a.m., it's not the time to spend half an hour saying, actually, averaging percentiles is bad. So pick the right time and place for figuring out when you want to tell someone some information. And you might be thinking I never do that. What are you talking about? And I want to show you a real, actual clip of what you all sound like. Maybe the Wi-Fi is going to work. I have the video on my laptop, so. Oh no, there's no audio. Oh man. I forgot to test that this morning. Okay, that's okay. So this is a clip from Friends. The guy in the red shirt says, we cut all these rules from the game because they were too complicated. And Joey says, what are you talking about? All you do is cross the waterfall, jump up through the monkey hoop, and then you touch the golden shrine. It's a really great clip. I'll post it on Slack after, but it wasn't necessary to this talk anyway. The great thing is that the Wi-Fi worked. The sound didn't work. So I want to give an actual example of this. The metric, so here's an alert. I want you to all just think for a second, what do you think this means? And I'll tell you what I've heard from our engineers, what they think it means. They think it means when I have my time series metric, anytime it passes the number 5, then I will alert. And some of you might think, oh, well, you shouldn't do that, because if the line keeps spiking up and down, maybe it's an anomaly, it's not an alert. And so maybe you want to wait a little while, or maybe you want to do something different. And so at Pinterest, what this actually means for us is that we take the last 10 minutes of data, we aggregate it in some way, we make it into an average. I'm sorry if you don't like averages. I'm learning. And then we compare that number to 5. So we don't compare whenever the line passes 5, we compare more than one data point. And not everyone at Pinterest is aware of that, so they might think, oh, it's just when it passes 5. And that's a huge misunderstanding for us. But going and sitting down with every single engineer and telling them all of this information, it's not that helpful, because they're going to zone out. They don't care. They just want their alert. And so we built this tool, and I'm not sure it says aggregate series by average. I had a huge debate with my team where I said, I think this should be a longer sentence where you say, take the last 10 minutes of data and blank it and blah, blah, blah. And I was trying to write a whole paragraph on our alert preview script. But then we realized nobody's going to read that. So aggregate series by average is fine. And then if people want to know more, they can ask us. And then we can tell them our long 30-minute explanation for alerts. The more important thing is that we wanted a different way for people to think about alerting without having to think about all the details. And so if you give a user a preview and they can say, this right here is where I want my alert to happen, then they don't have to think about all of the details. They can just keep tuning and tweaking until the red parts highlight where they wanted the red parts to be. And so we realized that's all people see, and they don't really care too much about the form underneath it. And there is a place in which you can explain all of the things that you want to talk about. In our case, I wanted to tell people all about like why OpenTSDB is different from Graphite, and I realized no one cares as long as they can get their data somewhere. And so we wrote up a nice little explanation for what OpenTSDB is and what Graphite is, and hopefully maybe someone's read it, but maybe no one's read it. But this means like I can hold my opinions on the inside, and all of our engineers are saved from me telling them too much about monitoring. So the next thing is your best practices. This is where you get to shine. We have so many opinions about how to do monitoring right, and so you can take that expertise and you can think about what the default behaviors in your tools are and then just choose what's best for your company. Yesterday, Betsy said that math plus context is a really great thing, and I would say at your company, your expertise plus the context of your company is really great for you. In our case, maybe we do want our alerts to look like averages and what I just said in the previous slide. But maybe for you, alerting should mean something different. And so that's up to you to decide. In our case, we fill out the form automatically. Before we didn't automatically fill out all these fields, so people have to decide how many minutes do I want to do, how do I want to aggregate, how often do I want to check. And then as soon as we just added those fields by default, people could just ignore it, and they could use what we'd already suggested for them. And so if you think that alert is best done by aggregating by average, then you can just make that the default. If you think something else is better, you can make that the default. And then the last thing, which ties back into the previous point, is that you can guide people away from things that they shouldn't be doing. So make it hard to do the wrong thing. And going back to the previous point, a lot of people by instinct want to aggregate by final point, because you would think if you're aggregating by final point, then that means what I was just describing. People want to know when their alert has passed the number 5. And so you'd say, oh, the final point, that means take the last point in the data and check on that. And for us, that is the wrong thing to do, because it takes about 5 to 15 minutes for all of the data from all of our hosts to report to OpenTSDB. So if you take the final point, then that's not whole data yet. And so we try to guide people away from using final point by making average the default. I got shot down when I tried to suggest that maybe we should take Clippy, and every time someone has a final point, you could be like, hey, no, you don't want to do that. So we don't have Clippy. I'm still hoping that we will have it. But right now we don't stop people from using final point. We just kind of bury it so that you have to actively choose to select final point if you want it. And next we want to talk about designing what your users want. So the first thing is that your users are having a lot of feelings when they use your tools, and almost all of those feelings are negative. The first one is that people are just angry. Nobody wants to be using your tools because it means there's probably something that's wrong. So in terms of like frustration, the most important thing you can do is think about performance. So you want to do whatever it takes to make your tools fast. And when I say that, you're probably thinking of some really traditional ways of making your tools fast. So here, I want to give a survey of some low-hanging fruit that our team has been considering over the past few months. So on the back end, you might roll up data over long time ranges. Like if you're saving at 10-second resolution, you probably don't need to do that for a whole month. So maybe you want to, like, for 24 hours, you want to roll up over a minute. Maybe for a month, you want to roll up over a day. That's really cool. You save some storage space. Maybe you want to store the latest data in memory, so you have like an in-memory time series database. You serve the last 24 hours of data really, really quickly. I really recommend the Facebook Gorilla paper and their open source BurnGate project if you want to learn more about that. And maybe you want to add a cache, which we did, and so you can serve the data more quickly. But, like, yeah, whatever. Get back to me in 6 months. That's going to take forever to do. These projects are really significant engineering challenges that will make your product faster, but it's not exactly a low-hanging fruit. And so what I want to talk about is, like, there is some really simple UX or UI tricks to just make people feel less frustrated, even if the performance is still the same. And so you can reload data you can not reload data if the user changes the time window. So in our case, people were complaining because they're like, I loaded up 2 hours of data and then I changed it to be 6 hours of data. Why did I have to reload that existing 2 hours of data? Why didn't I just reload what was not in the browser already? So that's one cool thing you can do. You can do some AJAX magic and make that happen. You can prevent the user from requesting data incessantly. In our case with OpenTSDB, if you make too many requests to OpenTSDB at the same time, somehow none of them respond. I'm not really sure why, but that's a thing. And so in our case, if you detect that the user is like refreshing the page over and over because they think it's timed out, just stop them. You can do that. And that's one way of lightening the load on your OpenTSDB instance. And then I remember a vendor from a day ago or so maybe said that they lazy load graphs on their dashboards. And I thought, oh, that's cool. That means that maybe I'm being validated here. You can lazy load your graphs, and that's a good idea too. And as a disclaimer, we haven't done all of these things. I wanted to just give a really quick survey of everything that we're thinking about. And I know there's probably an entire 45-minute talk that can be done about performance and monitoring. And I think that's really interesting. I just want to say that performance is a part of your user experience, and it's a huge deal. And so that's one way you can make people less frustrated when using your tools. The second feeling I think people have is anxiety. People are afraid because, one, they're not sure if they're going to lose all their progress. Maybe they've built up a huge series of data that they really like, and they're afraid that if they click away from it, then they will lose that data. And that's how you get tab hoarders. So you want to make it easy to try things without fear. And then the other fear that people have is that if they click around too much, maybe they'll make an irreversible change. And so you want to make people feel like it's okay to explore your tools and look at metrics without feeling like something's going to explode. And in our case, we have this really nice ad hoc graph explorer where you can do a lot of really fun things. You can, and in terms of how we make it possible for people to not feel scared, we make it so that you can use your basic browser features. And that's not something every tool does. In our case, we realize that people want to just be able to refresh the page and have the same data show up. You don't just want to see the StatsBoard homepage again. You want to be able to click the back button, and if you see a metric, if you type in a metric and then you move away to another metric and you type something else in, you hit the back button. You want to see what you saw before. And I know that this might sound obvious, but again, if you're building a tool and you're using a ton of AJAX and a ton of JavaScript, you might have broken your back button, and you want to make sure that those things still work. And you want to make sure that your URLs are RESTful, meaning if I copy this and I paste it in Slack, I want my coworker to see the exact same graph that I'm seeing. I don't want them to just go to the StatsBoard homepage. It's really important. This drives me freaking crazy. I really want all of you to do this. So on the side of so that's how we make people feel okay with exploring. And on the side of making sure people don't feel like they're going to break everything. Before, the only way that you could build an alert was you would type out your configuration in a YAML file, and then you would run StatsBoard locally on your own machine, the entire web app, and then you would run your alert. And if you forgot to put the no-op flag, you could get emailed just by testing out your alert. And people hated that. And so we realized people want to explore their alerts in a way that doesn't alert them. And that's one way you can make sure that people don't feel terrified of running your tools. And the third thing people feel is they're confused. You want to make it really easy for people to figure out what to do. And in our case, what that means, oh, I forgot about this. This is what you all look like. I forgot I include this gift. So you're all thinking you're over here I built these great tools and nobody likes them. They're wrong. And that's not true. If you think of your engineers as customers, then you can say the customer is always right. If you build a tool that people are confused by, it's your job to make it less confusing. And so what I mean by that is, here's a picture of our previous graph builder. It's a notebook style where you can type in the metric and then it will show up and it'll keep appending more and more graphs to your page. And I thought it was a good idea because you can see the history of your graphs. You can see how you got to the final result. And I don't really know why, but all of our engineers hated it. They were like, why doesn't it just show the last graph that I saw? And so maybe there's more psychology research we could do to figure out what that was about. But the point is that people didn't like it, and that means we have to change it. And another really huge problem with this approach was, you can see at the bottom, there's just a single text input. And let me talk about how we used to do metrics. This syntax, you would have to know what the name of your metric was somehow. Like maybe you wrote it down on a sticky note somewhere and you just got to type it back in. You got to know what all of the aggregators are for OpenTSDB are, and there's like 20 of them. You can do some or average or like some other extreme stuff. And you have to, like, good luck knowing all of your tags. You had to just know that this metric would have this tag and type it in, and I don't really know why we did that. And then bonus, if you wanted to, you could have a downsample, but you didn't have to include the downsample. So most people were typing things like sum, metric, and then tags, and then didn't even realize that there were so many other options that you could include in this weird string that we tell people to build. So what's the point of that? Why would we make people do this when we have to parse it out and then throw it into a JSON and then post it to OpenTSDB for them? That's garbage. So now we have this really nice UI, as I'd already shown on previous slides, where you can go in and fill out the fields that you want. And so, as I mentioned before, we use Graphite and OpenTSDB, and most people don't care where their data is coming from. Like 90% of our metrics come from OpenTSDB, so we make that the default. If you know that your metric comes from Graphite, you can go and click and change it over, but most people don't care, and so we don't tell them where their data is coming from. And so you can ignore the rate and the downsample and the aggregator if you want, but it's there for you. And then we realized that tons of people like typing out things, like you don't want to always mess around with all those UI elements, or maybe it's an accessibility issue, to be honest. So if you start typing and you include a curly brace or a colon, then we'll just switch you over to to manual entry for power users, where you can type out exactly what I showed in the previous slide. And then for the tags, we fill out all the data that you need so that you know here are the tags that are for this metric. And then grouping and non-grouping tags, that's a new OpenTSDB feature that was just released, or we just upgraded a few weeks ago, so that's a new feature too, that we make it really easy for people to use. And so that's what I mean by designing what features your users want. So there's so many feelings here where you're mad all the time, you're confused and scared, and that's how we should be thinking about how people feel when they use our tools and doing as best as we can to make those feelings less terrible. And so to recap, we started at the fastest way to become a 10x engineer is to help 10 engineers do better. And with our tools, we can do that. With our documentation and our team culture, we can make it so that people feel really good about doing monitoring. We talked about exactly what I just said. We have the tools, but we have the documentation and team. And maybe one day we can all spend millions of dollars per month and have a vendor. And then we talked about how to share what you know. Think about when it's time to educate people versus when it's time to just let people feel out what's right. When it's time to use the best practices, or I guess the time to use best practices is all of the time. And then you want to guide people away from doing the wrong thing. And you want to do these ways subtly so that people don't have all this cognitive load when it comes to using your tools. And then you want to design what your users want, which is not always what you want. Our team really liked the notebook format. People like the UI format. It's great. We can have both, honestly, because we built our own tool. So you want to think about performance. You want to think about how people can explore without feeling scared. And you want to make it as simple as possible. I'm not sure how I'm doing on time, but thank you. I think I have time for questions. Or no questions.
What graphic library are you using?
Oh, that's Rickshaw. It's an open source library, and you can find it on GitHub.
What did you put OpenTSDB on?
We use HBase. Oh, I'm sorry. Okay, so the first question was what library are we using to make the graphs? That's Rickshaw. The second question is what do we run OpenTSDB on? That's HBase. You in the back?
How does all the feedback for this tool come from people finding you and going, this is the problem, or you do user research as well, and do you put time aside for that when you're building all of these tools?
So the question was how do we figure out what the feedback is? Do people come up to us, or do we send out surveys? So there's a lot of different things we do. We send out a quarterly developer survey where we ask people how they feel. Oh, there's a phone. Oh no, someone's on call, the ground's on fire. Okay, so it's gonna go away soon. Okay, or not. So we send out a quarterly developer survey where where people can fill out from 1 to 7 how they feel about many different aspects of our tools. I will admit that StatsBoard, our tool, has always been around like the dead middle, like some like high 3 point something to 4, which is not a great score, and so that's why we realized we needed to change. We also happen to sit right next to our site reliability team, so they will tell us how they feel immediately. We also have a Slack channel where people can go and ask questions, and so we kind of keep track of like what kinds of questions are people asking a lot of. We put those in our wiki, and we use that information from what questions are being asked to figure out what needs to be built. All on the right?
So, approximately how many people would you say work on visibility and observability?
At Pinterest,
How many would you say focus on making the UX and UI better?
okay, so the question was how many people work on visibility at Pinterest versus how many people are working on UX specifically. So our team size is we have 1 manager and 7 ICs. And one thing that I didn't mention is that about like 8 or so months ago, I was doing a ton of the JavaScript work, and I realized like I don't know JavaScript. I was like doing this weird vanilla like DOM manipulation with jQuery, and it was a bad time. And so we actually hired a front-end engineer to develop on all of these tools. And so what I got to do after that was like I could just draw pictures of like what I thought people needed and explain to our front-end developer like, here's all the background knowledge you need. And then he was able to build all these tools with like our combined powers, which I thought was really fun. I would say the front-end developer and I would work together on this. I would say that it was more of like a passion project for me to make user experience better for everybody. The other 5, I can't count, 5, 4, whatever. The rest of the engineers work a lot on like making sure OpenTSDB is stable, making sure our entire metrics pipeline is stable. So that's more, I guess that's more traditional monitoring work or visibility work. I saw other hands. Yes.
Do you have any problems with like migrating developers to new tools? Like,
Yes.
they're really obsessed with the tools they have, and then it's really hard to make them use the new things.
Okay, so the question was, do we ever have problems migrating developers to tools? I need like another hour to talk to you about all the mistakes that I've made in the past year of doing this. I think because we have our own web app, it's okay for us to, if people like the old notebook format, we just tell them where the endpoint is. Like you can just type in the URL and it's still there. Maybe that makes us a little bit of like a hoarding team, but like there's no point in deleting the notebook format if some people like it, for example. So some of our teammates actually still use it, even though through the StatsBoard UI, you automatically go to our new form-based metrics. We actually did migrate from ELK to Sumo Logic, and that was a like long ongoing process of getting people to switch. So the answer is yes, there's problems. I don't think I have time to tell you all the problems. One more question. Hat.
So when you make changes in the UI, I guess you have your hypothesis on why you're making certain changes. You have ways to validate quantitatively or qualitatively the impact of those changes.
Sorry, I didn't hear the end of it. Was it that you're asking how do we think about like whether or not our changes were positive? Was that the question?
Yeah, like I guess you make changes because you want to have an impact on the users. How do you validate that impact?
Yeah, so as I mentioned before, okay, so the question was how do we validate that our changes were positive? One fun fact is we're having tons of OpenTSDB problems right now because people are so excited about making alerts on the new thing that they're making a ton of alerts. And we can't handle that volume. People are like, requesting like an hour of data every 30 seconds, and it's terrible. So we actually do know from our, just our load that we're letting people make too many awesome alerts, and we have to deal with that. And then we have the developer survey where every quarter we ask people for feedback, and our number has increased. So I think that's and people that left comments like, StatsBoard is awesome, it's changed so much, the documentation's better, and all that good stuff. So I think that's one way we validate. Okay, cool. Thanks a lot.
All right, it's sponsor time. I'll introduce you. So a few quick notes before we thank our sponsors. There are 2 events to think about tonight. One is a hike, which is with me. Yeah, sorry. And yesterday it would have been amazing, but today it's just going to be kind of chilly. We're going to go up to the rose garden, and there aren't a ton of roses yet, but there are some. And depending on the clarity of the atmosphere, we can see some mountains. Cool. I didn't make the mountains. And then there's another sponsor event, I think at 6 o'clock, and I'll share more details about that on our next break. But we're going to have quick sponsors. And up first is NS1.
Hi, everyone. I'm John Sullivan, one of the co-founders and chief product officer of NS1. I'm going to talk to you today about DNS, which immediately begs the question, why are we talking about DNS still in 2017? The protocol is about as old as I am, and it's still key to delivering nearly every application on the internet, mobile, desktop, it's all still tied to one system. Over the last 10 years, we've seen a lot of technology and frameworks and hosting companies come up that have solved a lot of scale-out problems. And so if you're building an application today, it's distributed from day one, either for disaster recovery purposes or performance reasons, because now you do care about the billion users who are online in China. And DNS hasn't really kept pace with that. 10 years ago, it was a real estate transaction to get a server. Now you have Packet, DigitalOcean, Amazon. You push a button, you have servers in 20 locations. And a new problem, how do you get the users to the right locations? And most of the providers out there kind of function like a GPS from the year 2000, where you type in Home Depot and it knows which one is close to you. And if it's fancy, maybe it knows the store hours, which in this strained metaphor is monitoring, I guess. But it doesn't know if the store is on fire, what the traffic is like getting to there. And so we thought we could do better, frankly. So what makes us different from every other provider? The first is we have rich metadata support, and I'll dig into what that means in a minute. We have a routing engine called Pulsar, which has telemetry from your end users to your applications, to your content delivery networks, to all the major hosting providers, so that we have that Waze-like, Google Maps-like traffic information about the broader internet. And then the technology we use to tie all that together is called the filter chain, which is a way of expressing your very complex routing algorithms in a nice, elegant, easy-to-use way. So I won't bother reading all of these, but you can do that. These are all the different things that you can tell us about a server or a facility or a content delivery network. You can tell us if the request is coming from a particular ASN, route it here. You can do IP prefix filtering. You can set watermarks and do qualitative load balancing on connection counts. You can feed us aptX information from New Relic, all sorts of cool stuff. And the way we do that is by kind of recognizing that there are a lot of companies here who specialize in this kind of stuff. And we didn't think it made sense to reinvent the monitoring wheel as it's still evolving. We do have native monitoring built into the platform, so we can probe your data centers and look for response codes from a distributed monitoring network. But that's really not a great way to do load balancing. So on the left-hand side here, you see all the monitoring companies that we integrate with. We also have a nice REST API. So you can beam in metrics from any source of your choosing. People doing all sorts of crazy stuff. And on the infrastructure side, we have integrations with things like load balancers. So you can send us connection counts from your Elastic load balancers, for example. And if one gets to 95% utilization, because you're not using autoscaling or something, it doesn't really make sense to let that fall over and send traffic ping-ponging to the West Coast or to another availability zone and cascade and cause failures or things like that. So we can keep the utilization at 95% or whatever it is you're comfortable with, and then gracefully bleed traffic off to the next nearest option. In terms of visibility, we have a lot of outbound integrations as well. We do record level reporting, which is pretty nice, and you can get that out into Grafana. And our monitoring as well integrates with chat and webhooks and all that good stuff. And we have a load of toolkits so that we really integrate. It's less of a utility or a commodity, and we can integrate in both directions with your stack, so you can make better routing decisions. And then this is the filter chain. This is how you would describe an algorithm that effectively creates like a content delivery network, for example. So the up filter might be powered by our monitoring, and if we detect a failure, we'll remove an answer from rotation. Then we can sort by proximity to the end user. then we could look at our pulsar data and say, what do we know about this user in this geography on this ISP right now? What are we seeing in the last 5 minutes? Should we re-rotate or resort based on that? Are any overloaded? If so, let's throw those out too. And so the end result is, if you open like the Yelp app on your phone, rather than sending you to the closest data center, we'll say, oh, this user is on Verizon Wireless in Oregon. Based on what we're seeing right now, we should actually send them to the East Coast data center because there's congestion or fiber cuts or something going on in the data centers. We deliver it in 2 ways. One is a managed DNS platform, which we're all familiar with, so 25 node, globally anti-casted, super fast, powerful network. We also deliver it, those same infrastructure as Code Trends and Ansible and those hosting providers that make it easy to get infrastructure. We also deliver it as a virtual appliance, and so we can deploy a totally separate physical anycasted network with our friends at Packet, for example, and give you sort of dual DNS providers with the same technology powering both of it, so you don't need to worry about feature parity or attacks against one network affecting the other. And then I already talked about Pulsar. So that's it. Thanks. Like everybody else here, we're hiring. If you'd like to come fight Mirai on the edge of the internet, this is a good place to do it. And lots of other interesting challenges as well in metrics and monitoring and all of the themes that everybody's been talking about. So thanks very much.
And our next sponsor is Outlier.
Sorry, excuse me a second. I bought a new Mac, so I've carried it around all these bloody adapters. Okay. Sweet. Okay, yeah, I'm calling from Outlier. We were the ones that kind of did the Make Monitoring Great Again hats last year. I don't know if you got a chance to pick one up. They went down fairly well. We thought about doing it again this year, but it turns out it's not so funny when the nightmares become true. So we went with T-shirts instead. So yeah, we're a SaaS-based monitoring tool. I know, you're thinking, great, another one. But yeah, we've designed for kind of people that don't really want or don't have time to spend all of their working day kind of setting up open source tools and kind of plugging them all together. And so we try to kind of take that pain away and allow you to kind of set up your monitoring as quickly as possible using our out-of-the-box integration, as well as being able to write your own custom checks against your custom applications that you might want to be monitoring. So, as we know, monitoring isn't a destination. It's never done. It's a constant journey. Your kind of setup is constantly evolving. You need to iterate on your monitoring setup. And this gets harder as you move more into the world of microservices and Docker and the ephemeral nature of those kind of dynamic environments. So there's a great talk a couple of years ago on the kind of this OODA loop pattern and how with the current tools that are out there, more so back then, but how painful it is to build these systems and be able to quickly iterate on your monitoring setup so that you can iterate on things quickly. But then, so we kind of think there's a better way of doing that, and so we tried to kind of make the process of building your agile monitoring and working on getting the data out of your system as quickly as possible. So in the application, first stage is you go in and start building your check script. We built an IDE straight into the application, so you just do that in the browser. We also support Nagios check scripts out of the box, so you don't even need to do this first stage. You can go to the registry, grab one, dump it in the application, and barring some configuration properties that might be in there, you can just run it straight away. And we allow you to build these and test these within the browser as well, so you can pick hosts and specific hosts to run them against and containers. Once you're done with that check, you're kind of happy with it, it's all built and running, you can then specify the deployment of which host you want this to get run against. And again, we do all this via the browser. You can deploy it to hundreds or thousands of hosts within minutes. And the aim is that once you've installed the agent, our deployment is via an agent, then you never need to go back to those hosts. You can just do it all centrally. And then once you've got that deployed, the points will start coming into the system. You can start building custom dashboards around those. And you get the points in within seconds of them running. So there's no waiting around for 5 minutes waiting for a data point to come in so before you can actually start building anything. And then once you've kind of got that set up, you tend to be building these things as, in an abstract manner. You want to share them around, so you can either share them with the community or share them within your organization. And we support a mechanism called a pack, which allows you to bundle a bunch of this kind of monitoring configuration up into one component and then distribute them around. So you can use our kind of command line tool for doing that, or you can kind of export them to GitHub and allow people to access them that way. Yeah, so we do all the traditional things you would expect from a monitoring tool, obviously collection, visualization, and alerting, but we've also built a kind of a GitHub style account model based on that as well. So it tends to happen is that your operations team will set this up, and then they'll create accounts for the different teams in the organization so they can do their own monitoring. Then there's no kind of, there's no bottleneck waiting for people to configure the monitoring. And then that also means it makes it easier for you to be able to put your devs on call as well, because they can have their own account, they can go in there, change their monitoring configuration, define their own alerts, update their own alerts, and basically take control of a self-service environment. So yeah, we're kind of, we have quite a few large customers now, so we're deployed on stacks with thousands and thousands of servers, so we have a reliable system and backend to support all these. And we become like the single pane of glass for these guys because we support open standards and things like that, so they can ingest their data, push their data into our system. And that's all I had. Thank you for your time. Yeah, feel free to sign up at outlier.com and give the product a whirl. So, cheers. Thank you.
And our final sponsor is CatchPoint.
Hi, I'm Dawn Parzak with CatchPoint. I'm here today to talk about bias, perception, and metrics. Who here admits that they're biased? Who here thinks they're less biased than other people? That's a bias. It's called a bias blind spot. I'm biased. I'm biased towards CatchPoint. I think we have the best digital experience monitoring platform on the planet. But that's not what I'm going to talk about today. We're going to look at how our biases can influence the way we look at data and present it. With over 180 different biases, there's one that's bound to creep into how we look at metrics, how we present that information, and how we perceive it. 6 seconds. Is that fast or slow for a web page to load? Chances are you've read studies, heard people talk about 3 seconds. People won't wait longer than 5 seconds. That's an anchor. And it leads to what's called an anchoring bias. Anything now you're going to think over 3 seconds is slow. If I had started saying a web page loads at 10 seconds, after months of engineering time, they got that page to drop by 40%, and it now loads in 6 seconds. As a user, you'd probably think that was fast because your anchor was 10 seconds, not this 3 seconds that you've been told is slow for a page to load. Anchors influence how we look at data. The other piece that comes into play are vanity metrics. We all want our companies to be successful. We all want our teams to be successful, so we look at the metrics that are going to show us in the best light. This is a confirmation bias. We don't present the data that doesn't look good. We only present the information that makes us look positive and everybody can celebrate and say, yes, we're doing great. But you can't really do a lot with vanity metrics. So focus on whether or not you're presenting data that supports a confirmation, that's confirming your hypothesis that yes, we're successful, we're doing well. Our brains want to make sense of information. Even though half of this is covered, your brain reads this. I'm sure you're reading this as jumping to conclusions. That's not what this says. This doesn't make sense, so your brain isn't going to think that this is what was there. We look at patterns, and through those patterns, we extract information in a meaningful way. This applies to data as well. We talk about averages. Averages are meaningless. These two charts give you the same average. I personally like the dinosaur a little bit better. I don't know what that tells me about the performance of a system, but I think it's a cool looking dinosaur. Autodesk has about 12 different charts that they've created that look very different, but they give you the same 4 statistics. So don't just present a statistic, visualize the information. Because visualization is so important, that's one of the reasons that Catchpoint provides a number of visualizations on our platform. And if you don't like the ones that we've provided, you can bring your own visualization to present the data in a way that makes sense to you. And maybe it'll look like a dinosaur. So bias is all around us. We can't overcome it because it's ingrained in who we are. But there are some things we can do to attempt to avoid it. The first piece is admit that you are biased. That's something that everybody here admitted to, but realize how these biases are influencing you. When looking at data, create your own anchor. Benchmark and baseline your performance before you sit down and say, this is the goal we have to achieve. Because once you put that data out there, everybody's going to want to hit that number. And if it's too far out of reach, you're in trouble. Create an environment where people can ask questions. And it doesn't matter who the person asking the question is, whether they're a junior engineer, a senior engineer, or God forbid somebody like myself that's in marketing. Allow them to answer the questions and accept the answers that are provided, even if it doesn't confirm what you want the data to say. Thank you.
All right, we're heading into a break after our final speaker of the morning. And I want to make 2 quick announcements. First, if you don't want to go on the hike later today, I'll feel sad. But you could also go to, I believe it's the Stack Storm thing at Bridgeport Brewing, which is close to here, at 6 o'clock. So that's if you don't want to go on the hike with me. And then there is coffee outside ready for you on the break. There are also extra socks, and you're welcome to take an extra pair of socks. We request, recommend, suggest, in the spirit of Roy Rappaport, that you make a donation to a cause that you care about if you do take an extra pair of socks. Okay? Cool. Thank you for agreeing with me. So please, a warm round of applause for our final speaker before the break, Kishin Rong.
Cool. Hi everyone, I'm Ke-Xin from Stanford. Today I'll be talking to you about some new research project that we are doing on how to automatically smooth your time series visualizations in your dashboard. I am currently a PhD student at the Stanford InfoLab, working closely with Professor Peter Bayless and Matej Zaharia. I'm really interested in the monitoring space. I think there are a lot of cool problems to work on. So the project that I work on is called Macrobase, which is a system for diagnosing and analyzing anomalies in monitoring. And really excited to be here. This is my first time in Portland and my very first conference talk. Thank you. Yeah. So we're here talking about problems and solutions in monitoring. And one problem that we notice is that the time series dashboards that you guys are reading every day are often noisy. By noisy, I mean sometimes the spikes or fluctuations in the time series can really obscure the overall trend. So here is a plot of my CPU usage over the past 5 hours. Maybe from reading this, I can see that there might be something going on at 4 or 5 a.m., but in general, this is really hard to read. So imagine instead, if I apply some amount of smoothing by a moving average, I would get a much cleaner graph instead, where in this graph, I can see clearly that there are some spikes in my CPU usage, and also overall, my usage has been slowly increasing, which was really hard to see in the original graph. I don't know about you guys, but if I were to get woken up earlier in the morning to see, due to alert in my CPU usage, I probably rather see the latter plot. So this is what we're going to talk about today. How do we automatically generate a smooth plot like the bottom one? This is some ongoing research that's motivated to generate more informative dashboard visualizations. And our idea is simple, that you should consider apply some amount of smoothing to your dashboard visualizations. And in this talk, we're going to go deeper into how to actually set a good default smoothing parameter for your visualizations. Why do I care about smoothing in the first place? Well, we actually did some user study, and it showed that by setting the right amount of smoothing parameter, it actually did make a huge impact on users' ability to identify deviations in time series. So specifically, we saw an up to 38% increase in accuracy and 44% decrease in response time for users to identify deviations in time series by applying smoothing. So we also implemented the above algorithm in a JavaScript library called asap.js that you can try yourself. So going back to this problem of what do my dashboard tell me every day? We see that many dashboards by default just plot the time series as they arrive. We ask, is plotting raw data always the best idea? To illustrate this question, maybe it will be helpful for us to walk through an example where here I have plots for two CPUs, usage of two servers on my cluster. From the time series plot, it might look that these two servers are behaving kind of differently. But it turned out that if you were to perform some amount of smoothing, they actually show almost the exact same usage trend, which was really hard to see in the original plots because they were hidden under the fluctuations. To further illustrate my point how fluctuations can really obscure the overall trend in your visualization, I have another example data set where I have 250 years of monthly temperature data in England. I tried plotting this in Excel, and here is what I got. So on the x-axis, I have time, and on the y-axis, I have the average temperature. Well, in retrospect, actually this plot makes sense because temperature always goes up during summer and goes down during winter. So when I have 250 years of monthly temperature, that means I have 250 fluctuations, which is 250 spikes all compressed together in this visualization. To make sure that I'm just not picking on Excel, I actually tried plotting the same time series on some of other awesome monitoring tools that I've heard of. So, for example, Grafana, Prometheus, and Tableau. Well, don't take me wrong, I totally think these are great tools, but wouldn't it be nicer if my tool can automatically smooth the time series for me instead of having me go through the process of finding a parameter and doing the actual smoothing? And I don't blame the vendors because it is a challenging problem. As you can imagine, the right amount of smoothing probably varies a lot from data set to data set. So how do we come up with some guideline for doing smoothing that would apply to multiple data sets? Turns out that in this case, if we were to perform smoothing on the time series using ASAP, you will see this trend line. Despite some fluctuations, you can see that around 1900, the average temperature started to increase, which is not surprising considering our temperature is warming right now. So a little smoothing can really go a long way. To summarize so far, why it's not always a good idea to plot the raw data, we see that it's really, in many cases, our attention are grabbed by the spikes that's present in time series visualization. So if we zoom into this small area in the CPU usage graph and then expand it, we see that this is essentially a series of fluctuations compressed together. But they're really overrepresented in this final visualization relative to overall trends, which is making it much harder for users to tell what's going on in the system. So far, we've observed that raw data is often noisy. And we've also seen that some amount of smoothing usually helps. So, yeah, cat memes are always good for talks, I figured. So, yeah, next we're gonna go into more details on how do we come up with a good smoothing parameter for removing these fluctuations. So the first question that I have naturally is, if I want to do smoothing, what smoothing average should I use? Well, it turns out that moving average are fairly general and they actually work really well in practice. So to be really clear on what I mean by moving average, maybe let's just walk through a really simple example where I have 6 points in my time series and I want to smooth it using a moving average of window size 4. So here I would take the first 4 points in my time series, compute their average, which gives me 2.5, and then I will slide the window forward, compute the average of the next 4 points. And I keep repeating the same move until I reach the end of my time series. And this new 2.5, 3.5, 4.5 time series is my smooth time series. And you notice that we can actually control the amount of smoothing here by changing the window size that we use for our moving average. So overall, in general, if you pick a larger window size that correspond to more smoothing, if you pick a smaller window size, you'll probably get a time series that's closer to the original one. And it turns out that there's actually signal processing literature that justify that moving average removes this kind of short-term fluctuations very well under many conditions. So it's really a great fit for our purpose, despite how simple it is. So great, now we have a smoothing function. Are we done yet? Well, there's still this question of how much to smooth or what window size should I use to answer. For example, if I want to smooth this spiky CPU usage graph and I apply a small window, well, you see that it helps a little bit, but I still have the remaining spike in the original graph that I want to get rid of. Compared to if I apply a window that is too large, then I get an increasing line. And because I smoothed away some of the spikes that's present in the original time series, I get a little idea on what's causing my CPU usage to increase. And monitoring is all about giving more context and making it easier for users to read. So here's what ASAP comes in. So ASAP stands for making your plots as smooth as possible, which also happen to have initials ASAP, while preserving the long-term deviations. So for the next part of my talk, I'm going to go into more details on what do I mean by smooth and what do I mean by preserving the deviations. So maybe first, let's look at smooth and how would I even quantify smoothness of time series. Here are two example time series. I think the red one is not smooth and the green one is smooth. I hope you agree with me. And so my goal here is to find some statistics that would tell me that the difference in smoothness in these two time series. So the first thing I thought of is taking the mean, right? Average is always good. Unfortunately, they both have mean 0. Well, maybe mean is a little too simple. So let me try something more sophisticated, like a standard deviation. Well, it turns out that they also have the same standard deviation. Well, taking a step back, I'm realizing that the reason why I think these two plots look different to me is because in the first plot, the points are going up and down, while in the second plot, it's a straight line. So if we actually calculate the difference between neighboring points in these two plots, we see that in the first plot, the difference is fluctuating between 2 and -2, while in the second plot, the difference is the same. So if I take the variation of these differences as a metric, then I see that the first plot has a variance of 4, while the second one has a variance of 0 because it's the smoothest possible line. Great, so how do we calculate this point-to-point variance exactly? Simple. Iterate through your points in your time series, calculate the difference between every neighboring points, and then you call the variance function, and you're done. So we already have the first part of the answer. We quantify smoothness in time series using this variance of difference between neighboring points. But so far, ASAP is just telling me to increase window size and decrease this point-to-point variance. But when should I stop? Because remember, the smoothest line is a straight line, but I don't want to make all my metrics a straight line. So here's where the second part comes in. What we're lacking essentially is some kind of constraint in our smoothing that will prevent us from going overboard. So for example, going back to the same CPU usage example, let's compare two smoothing for this time series graph. I personally like the first smoothing better because it got rid of the fluctuations while still showing me the spikes that happened throughout the time. While the second one is not as great because it smooths away more context in the original graph. And the difference between these two is essentially the good smoothing preserves some type of deviation or outlierness in the original plot. So maybe we could just use that as a metric on how to stop us from over-smoothing. It turns out that conveniently in stats, there is this function called kurtosis, which measures exactly outlierness of a distribution or a time series plot. So concretely, high kurtosis means that the distribution that's responsible for generating the time series visualizations have heavier tails and therefore easier to produce outliers, while as a low kurtosis means that the distribution have lighter tails and therefore your time series will look more uniform. Let's calculate the kurtosis of these three graphs. So the original one has kurtosis of 4.1. The second one has kurtosis even increased a little bit because I got rid of some of the fluctuations, so it's 4.3. While the third one, you see that the kurtosis decreased to 2.8 because I smoothed away some of the outlierness or deviations that's present in the original plot. And how do I calculate kurtosis? Since it's a standard function, you can just call SciPy kurtosis. Yes, but you can also do it yourself. And here's how you do it. You iterate through the points in your time series. For each point, you get the difference between this point and the mean and raise it to the 4th power. And finally, you divide it by the variance of the time series. And that's it. Cool. So going back to our ASAP statement, so for the first part, trying to make the time series as smooth as possible, we should increase window size to reduce the point-to-point variance. Where in the second part, to preserve the outlierness in the original time series, we should try to preserve structure, by preserving the kurtosis of the original time series. And the nice thing, I accidentally flipped the slides earlier, but the nice thing about kurtosis is that it also tells us when it's not a good idea to smooth. So here is an example time series that tells me the Twitter mentions of Apple on Twitter. And if you compare the original and the smooth time series, the only difference you see is that smoothing is decreasing the spikes in the original graph. So what's different between this plot and the CPU usage plot that I showed earlier? Well, it turned out that this original plot has really high kurtosis. It's like over 700 compared to the CPU graph that we saw has only 4, and the uniform distribution has kurtosis 1.8. So in ASAP, we have this rule kind of that if your graph have a lot of outliers to begin with, maybe it's not a good idea to smooth it. So let's just leave it alone. So congratulations, we've walked through ASAP. So just to recap, ASAP stands for as smooth as possible while preserving long-term deviations. So concretely, that means that we want to minimize the variance of difference between points by adjusting the window size of your moving average while preserving the kurtosis of the original data. As I said earlier, we implemented ASAP as a JavaScript library. So to try it, call asap.js in your front end, and before you plot the data, call this smooth function. So here quickly, I want to show you a demo website that I built using asap.js, where here I show, I have some preloaded time series before and after smoothing. So this is a time series of the taxi volume in New York City. This is the monthly temperature in England time series that I talked about. And this is a time series of power utilizations in a research facility. So you can also try uploading your CSV and smooth it yourself. Cool. Okay, so as I learned yesterday, ASAP now is also in graphite. So shout out to Bo, who I think is also in Monitorama, who connected ASAP with the graphite API. So he also even included a demo page on how it looks like in graphite. So you should check out his GitHub page if you're interested. Cool. So far we went through how to produce a good smooth plot using ASAP. So specifically by using a moving average to minimize the point-to-point variance while preserving the kurtosis of the original data. So to make sure that we're not just making things up, and smoothing actually do help users in identifying deviations in time series, we performed a user study with 250 people. For each user and each dataset, we show them an example time series. For example, here is a time series of the taxi volume in New York City. And we divide the time series into 5 regions, and we ask them, in which time period do you think a drop in taxi volume happened? In this case, this is the original plot, and the drop happened in region E due to the Thanksgiving break. And we also randomly show the users either the original time series or ASAP smooth time series. And turns out that for this data set, if you show users a smooth time series, users can have up to 28% increase in accuracy and also 44% decrease in response time in correctly identifying this deviation. We tried a similar user study on 5 data sets, and on average, we see like a maximum 38 increase in accuracy, an average of 21, and also a maximum 44% decrease in response time, an average of 24. So this really tells that sometimes if your data is noisy, you should consider some amount of smoothing. Okay, so far we've went over the problem statement, but I haven't talked about how exactly do I go about and find this window size I want to use for my smoothing. Well, the easy answer is just use grid search and try them all, right? So for each possible window size, I want to transform my time series. I want to check whether the transform one is smoother than my currently best one, and whether it preserves the kurtosis. And after enumerating all possible options, I report the best one. Well, as you see, this is an n-squared algorithm, so it's not very fast. And in case you're wondering, binary search doesn't work for this case because smoothness is not a monotonic function with window size. That means that it's not always the case where larger windows give you smoother plots. So that's part of my job, right? So I'm trying to make it faster by using the fact that at the end of the day, human beings, we are the consumers of these time series plots. So if we can tell the difference, then there's no point doing the computation in a sense. So first optimization we made is that, well, eventually you're going to see your time series on some kind of end device. And for example, if you use an iPhone, how many pixels does your iPhone have? Well, it turns out for iPhone 7, they have 1,300 pixels. What if I want to plot 1,000,000 points on my iPhone 7? Well, the truth is that given this limited display constraint, only a few window sizes is going to make your resulting time series look different. So our idea here is to pre-aggregate the time series according to your target resolution. And with this, we can save over 3,000x with iPhone 7. So bonus question, since you guys are all smart people, how do we go even faster? Okay, so the answer is just run it on your Apple Watch, right? Because Apple Watch have even fewer pixels, so you get even more speed ups. Great. So the second observation is that as you're in the streaming case where data continue to rise, the update rate actually matters. So here I have two dashboards that are streaming. And it might be difficult to tell just from looking at this, but actually one of them is updating almost twice as fast as the others. So the idea here is that even if data arrives quickly, we shouldn't update our dashboard according to the data arrival rate. Rather, we should update it at a rate where humans are comfortable or can make sense of. And the final observation is that a lot of times that time series are periodic, and if they are, we should really take advantage of that. So this New York taxi volume time series fluctuate on a daily basis because according to people's sleep schedule, they take more taxi cabs during the daytime. So given this fact, there is really little benefit in choosing a window that do not align with this period. For example, here I have two smoothing, one with a random window of 10 hours. So you see that with this window, I still get a lot of fluctuations in the original plot. Whereas if I smooth it using a day period, then the resulting plot looks a lot smoother. So what we do in ASAP is that we only search for window sizes that correspond to high periodicity in a time series. So altogether, what this optimization does is allow us to run really fast. So we went from the baseline where we can process 0.1 points per second by doing grid search on the original time series to adding in the pre-aggregation by pixel, adding in only search for window size that correspond to period of the data, adding in update lazily, and we get several orders of magnitude speed ups eventually, which allows us to hopefully be able to use it in a real production scenario. So that's all I have for this talk. Hopefully you will start to think about ways to smooth your time series visualizations by choosing some smart defaults. And smoothing empirically can help users better identify deviations in time series and identifying them faster. And if you're interested, please try using our library and tell us what you think. That's it. Thank you. I think I have a few minutes for questions, so please.
Have you considered trying to simultaneously calculate multiple kurtoses at the same time?
You mean, so the question is, have I considered simultaneously calculate kurtoses of at the same time? So are you asking like how to parallelize the search for window size?
Well, you say that you calculate over several sliding windows, but you already have the result of the earlier window size. So you could simultaneously calculate 3 and then add 1, and then you can calculate 4 and then add 1 and then calculate 5.
Yes, we haven't done anything really smart about how we calculate kurtoses yet. Right now what we do is we choose the window size, we smooth the time series accordingly, and then we calculate the kurtoses at the end. So the moving average part is O of n, so hopefully it won't be too bad. But I can see that there are room for making that even faster.
With the kurtoses, you said when it got too high, it lost its value. Is there some threshold where it's like a magic number where it says, all right, well, it's 200, this is too much? Or is it arbitrary?
Yeah, so the question is that is there a magic number for example, non-smooth time series according to some kurtoses? So the answer is I don't know. In the data sets that I work with, threshold of 10 works pretty good already because so to give you an example, the normal distribution only has kurtoses of 3, so 10 is actually already a lot higher than normal distribution. But I think the specific threshold probably, if you look at, try it on your data, you probably will have a better idea. Yeah.
You said you exploit periodicity in order to cut down the number of points you have to consider when you're calculating. How do you automatically detect periodicity? How do you know that data has a one-day periodicity?
Cool. So the question is, I said I'm optimizing by only search for windows that correspond to period of time. And how do I actually find that period, right? So great question. So we figure out the period in time series by using this autocorrelation. So autocorrelation is this measure of if I shift my time series, I compare my time series from the start to a time series that's shifted by some lag. How similar are these two time series? So autocorrelation will give us like a good indicator of like the window sizes that indicates high similarity. So basically what we do is we calculate autocorrelation for the time series, and if we see a window that correspond to, only if we see a window correspond to high autocorrelation, we search for that window. And the nice thing about autocorrelation is that it was also originally an n-squared algorithm, but then someone smarter than me figured that they can calculate it using FFT, so now it's n log n. Yeah.
Have you done any research into having different charts on the same dashboard with different window sizes and the benefits or drawbacks of the user experience? Like, hard to understand, or does it more confusing or less confusing?
Cool. So the question is, have I tried having a dashboard with different window size and then tried on users to see how they react? So the answer is, I guess, yes and no. So yes, because when we ran the user study, we not only did I try ASAP, but I also tried some other smoothing algorithms with different moving windows to let users look, and I asked them the same question of identifying deviations in time series. But on top of original and ASAP, I also tried a bunch of other algorithms. But if you go to the website, there is a link to the paper, and in the appendix, we show some of the results where we vary the window size, and we also measure the response time and accuracy for users on these alternative measures. So yeah. Okay, I think I'm almost out of time. So thank you so much for having me here, and I'm here to talk if you're interested. Thank you.
It's break time. Lunchtime. We brought lunch back for Wednesday. Please sit. Shh. Can someone grab the doors to the lobby? Thank you. Excellent, great. So I'd like to bring out our first speaker for the last section of the morning, which is Francois Conil.
Alrighty. That's a good start. I can't even open the laptop. I'm good with computer as well, generally, except when it comes to sound or AV, which is pretty much everyone else. Alright. Here we go. Monitoring that care, the end of user-based monitoring. So you're going to wonder, what the hell is user-based monitoring? And I'll go back to it eventually because, you know, that's the talk and that's pretty much what you would expect. But first I want a little show of hands. Who here has ever missed an alert? Because your phone was off, because you ate Mexican food, because you left it in the car, because you turned it off, because it's in another room, because you forgot you were on call, because you're still on another time zone, so on and so forth. I mean, yeah, all of us. Or almost all of us. If you haven't, don't worry, it comes to you. Especially when you have no backup. That's when you miss the alert. When you have no backup and it goes straight to your manager and he's not happy. But he's dealing with it anyway because, you know, that's what we do. We deal with stuff. Now, we go one up. Who has ever missed an outage? You go to the office and people ask you, where were you last night? Or, are you taking on call seriously? Or someone calls you or sends you a tweet or something like that saying, hey, is your website down? Yeah, it happened to me several times too. And that's not pager shaming. I mean, we all take on call seriously. We all take monitoring seriously. The problem is about coverage. Sometimes people use our services, our servers, our systems in a way we could not even conceive. It happens. It's really weird, but, you know, people do really weird stuff. And, you know, that's why we get paid. And my first reaction, and possibly first reaction for a lot of people, was to act really defensive, like mostly, computers, damn it. No, it's not down. Look, Nagios is green, or Isinga is green, or Sensu is green. Everything's green, everything's fine. But the end user doesn't care because that's all they see. They're like, I don't care if it's green. It's red for me, or white, or whatever the URL or message is. So obviously, instead of being defensive, you should rethink why people complain to you about things being down. Because deep down, why do they complain? Because they care, because they use your services, because they do not want to vote with their wallet. They actually like what you're doing, and they like it so much they want it to be up all the time. I mean, for instance, why do you stay up all night monitoring services? Why do you have alerts? Why do you get paged at 3 in the morning? Because someone using it. Your 3 in the morning is not my 3 in the morning. When I get back from work at 8 p.m. and I go on Amazon.com, not .co.au, and I want to shop and I put stuff in my cart and I check out and I can't, I'm really happy there's some engineer in Seattle that get paid at 3 in the morning to fix it because, well, I want to give you money. And it's even worse for some things. There's literally life or death situations. Imagine if the 911 switchboard goes down. If a self-help suicide hotline website goes down. You generally feel all right at noon, not so much at 2 in the morning when it's dark and you're alone. We need to remember why we monitor. We monitor because people use our services and we don't want them to basically catch us with our pants down because that means we failed them. And, you know, I'm not saying it's easy. We have pretty big names that got basically lots of message on Twitter, hey, is X down? Fill it with Google Cloud, AWS, Azure, GitHub, Amazon, whatever you want. It happens to pretty much everyone. It's hard. We just cannot cover everything. And even worse, we make it harder every day. I present to you the modern web service, an allegory. That's a simple one, by the way. I mean, there's maybe one key value store, two database, 3 different kind of front-end, 2 back-end, and all legacy AS400 somewhere in the basement because apparently we still need that. So that's easy. I mean, if you want to have full coverage, well, there's an easy solution. Just monitor everything. That works. I mean, you get vision on everything, you get alerted on everything, and your engineer wakes up to that. That's not my phone, by the way. I mean, I take on code seriously, and I've messed up a few times, but not that bad. So yeah, obviously you don't want that. That's not a talk about alert fatigue. We already know the well-known effects of not sleeping at all several nights in a row. Alice made a very great talk about it. If you haven't seen it, you should. So we have to refocus. We have to narrow down what we should monitor. And what we should monitor is basically what Alice said in the 4 rules of alerting, one of them being, does this impact the user? What would the user say? As an end user, I don't particularly care that you have 100% uptime globally on your MySQL cluster, or Percona, or Postgres, or whichever database you like. Good for you. I'm really happy. If I can't log in, that doesn't mean jack shit. Pardon my French. So you need to figure out what makes sense as a user. What do I care about? Can I log in? Can I see my profile page? Can I log out? That's a fairly basic test. That's the most basic you can have. I can assure you a lot of people don't even monitor that. Can I do those 3 simple operations? Log in, check my profile, log out. Not even browse, not even buy something or interact with something, just those 3 there. It's really hard. And so, how do you get to that point? Like, how do you know what your users do? Or do you know what they consider broken? Or do you know what they like? Or do you know how they use the product? I mean, we tend to, give a lot of bad rep to like support, sales, marketing. Trust me, they have a lot of reports. They hear it. They hear everything. Something's broken. I can assure you, there's 5 sales guys at your operation. So it's 5 sales folks at your organization that had lost a contract because of it. They're like, hey, by the way, that thing was broken 2 months ago, and we're not renewing because of that. Support hears about all the broken thing, and there's generally 3 ways to go about it, right? It's broken, and you don't care. You lose your user, but you're willing to lose it. Why not? It's broken for them, but it's not supposed to work that way because, well, what they call the bug is actually a feature on your end, and you're like, why would you do that with your API? That's not how it's supposed to work. Well, guess what? Talk to the docs team, because if there's no docs about it, what they do is what it's made for. And the third one, which is what we should go about, is, oh, well, it's broken and it's not supposed to be broken, so we should fix it. Well, yeah, but we weren't even aware it was broken until 15 minutes ago before I started. So, yeah, So that's it. That's great. You'd like, okay, so users, broken things. What do we do next? I don't know. What are we even measuring? Because right now, most monitoring is like, I think the application should respond in 5 milliseconds. So that's what I'm putting my alerting at. That's where I'm alerting. So I'm going to alert at the beginning and at the end. But turns out that's actual real-life values, not broken behavior. Just we did not measure accurately versus what we actually experienced. And we're busy. I mean, ops are busy, sysadmins are busy. We can't just do everything. We can't, once it's pushed to production, we just cannot keep watching it and be like, are my alerts correct and all? Usually you realize your alerts are incorrect at 3 in the morning, which is not the best time to make changes unless you're very brave or foolish or both. I mean, if you want another alert at 4, that's the best time to do it, definitely. So, you know, you're like, well, yeah, but maybe I need help. Maybe I need someone to show me what I should measure. And I'm sure that every organization has at least that one person that knows exactly how it should behave and what it should measure. And I'm sure none of you talk to them very regularly unless they tell you, by the way, your code's broken. Have you talked to your testers? Have you talked to QA? They know exactly what your application is supposed to do, under how many users, and how many times it can break. They know what's experience performance because they've done it before you push to prod. Talk to them. They know a lot of stuff. And sometimes, you know, they press all the keys at once just to see if they can blow it up. Usually it does. So, I mean, for instance, I have an anecdote, right? We're talking about the login, check your profile, log out. That was actually part of one of our SLAs in a previous job. And chance had it, I was volunteered to do it. I was like, yeah, that's easy. I'm just going to do 3 lines of bash, bit of curl, done. Well, it turns out a SAML application in Flash is really, really hard to manage with bash. You would not believe, it's really hard. And I spent possibly on and off 2-3 days on it, and I just could not get anywhere. I switched, I got wget didn't work, so I went back to curl, tried some weird libraries from the dark space of Usenet. I was like, oh, it's not working. And I asked the tester, like, so how do you do performance testing? Because obviously they're not logging in 5,000 times in a row to check that it's handling well, and that wouldn't work. And they're like, oh, well, this is easy. We're just using JMeter. I'm like, oh, but JMeter is Java. I don't like Java. Plus, there's a UI, and you have to click on things, and you have to click submit, and all. I can't do that at 3 in the morning when I'm monitoring things, and I don't even have X installed on that server. What do you want me to do? But, you know, at least I had one way to do it. So that was my backup plan. And I looked at their docs, and it turns out that the JMeter people are very smart people, and possibly some of them are sysadmins, because there's a CLI only option for JMeter, and it dumps a text trace of what you did. And all of a sudden, my monitoring problem was not. It was CSV files that returned 200, 301, 200, done. And I was like, oh, wow. If I get anything but that line, it means it's broken. It means I need to fix something, because I should not get 500, I shouldn't get 400 something. It was awesome. So yeah, talk to your testers. They know shit. The good one. So, I mean, right, so we know what to monitor, and, you know, it seems to be easy to just ask someone else to do it. And I bring that back to you for things. So where would you start to monitor it? The wiggly cog, the screen, the fondue kit? I mean, maybe there's a cow over there? I mean, that's the bell. The bell should be monitored definitely, because it's going to make some noise, so that's good. We like loud noises, you know, we like to be scared. Well, do you know who knows a lot more about that than you do? Your dev. And maybe you should have asked, you know, you should go in your little phone box or your DeLorean or whatever you prefer, go back 6 months in time and ask the devs, hey, could you put some clear logging in your app? Could you make easy to monitor? Like, can you not use Flash for SAML, please? Yeah, that didn't work, by the way. They were really, really keen on Flash. But yeah, if product, talk to your dev, invite them for coffee, go have lunch with them. I know they might be on a different floor. I had problems. I mean, I'm not saying it's easy. I've seen lack of communication in large organizations with like tens of thousands of employees, where basically devs and ops are in different buildings, in different cities, in different states, possibly in different continents as well. And I've seen the same problems in small 25 people organizations that were pretty much all huddled in a giant open space. It's hard, but it's so, so gratifying. Have lunch with them, ask for their opinion on how you should monitor things. trust me, they actually are really good with stuff. You just never ask them. And obviously, sometimes you can't. Sometimes you have legacy product, and no one knows Perl anymore, so you can't do that. I try to know Perl, I sucked at it. It's a great language, I just suck at it. Sometimes it's even worse. You get stuff like Fortran or COBOL, So, but you still have to monitor it because it's legacy, and legacy means money, means business. So you have to monitor it. So, it's tough. You still have to keep it running. You're paid, literally, because someone somewhere uses it and they expect you to keep it running. So you're back to that problem of the black box. You're like, well, I have my expected behavior. I need to monitor that. I'm just not sure where to start. First mistake, do not start coding. Turn off your computer. Get out. You always know that person who's like, I know, I'll monitor it with regular expressions. I have Nagios, I'm going to create you a nice little Python script. You're not going to believe it. Right, do you even know what you're monitoring? Yeah, I have the gist of it. Login, profile, logout. Yeah, easy peasy. Step back. Sit down, grab a notepad, do pseudocode, like back when you were in high school or in college, when you were starting doing Turbo Pascal or Basic or something. Do pseudocode. Pseudocode is awesome. You realize most of the time you have no idea what you were about to code, but you're already 2 pages and 5 branches in by that time. So, do it when you're still on Notepad and you can just use an eraser instead. And obviously, it's a very complex task. Sometimes it's like, okay, so I have to set up that new monitoring stuff. I have to create that new alert, but I also have to guarantee a time, and I have to deploy that thing, and possibly drive to the DC and rack up stuff, and look over that new agreement for the cloud stuff we're getting. How am I supposed to block a full week to do it? Well, you don't have to. You can just basically go with your ID and talk to someone whose job would be to gather requirements, to break projects in tiny little manageable chunks, to ask pointed questions about, no, when you're saying, I want a Python script to monitor my login, that's not what you mean. What you mean is, I want something that tells me if I can log in, check my profile, log out, or I can't. Some kind of people that analyze business or manage projects, usually they look like that, Haha, business. They're doing analyst things, they're managing things, they're product managers. But guess what? They're really good at taking really simple ideas, cut them down in manageable chunks, and transforming them into very complex, fully functional products. Because usually your MVP is, I have this dodgy hack in Bash, and it works fine enough, and you realize it's not working at 3 in the morning. And that's your MVP, and basically it becomes just MVP over MVP over MVP. You just have a craft of layers of MVPs, so it's just dodgy patches all around. And I know, I've done plenty, I'm sure. My name is somewhere on GitHub on some stuff I'm not really proud of. Really not. Don't go check, please. But, it worked eventually. But if you actually tackle it like a good, proper software development project, and I'm not saying, you need to have a gatherment meeting every day for 2 hours, because we're all busy. But ask for help. Hey, how can I fit that in my current workload? How can I work on it a tiny bit every day? How can I block out 2 hours a week to work on it? What would make sense? They would help. And they would be happy because they're like, you never talked to us before. That's great. You're actually a very nice guy when we know you. I didn't know ops people were so nice. I know, right? It's amazing. If you talk to people, they lose their prejudice. Amazing. And the last advice I would give you is obviously, because you're going to get a lot more alerts. Now that you know what to monitor, that you don't have any blind spots anymore, you're not getting less alerts. You're going to get more, a lot more. You know what's the key to get less alerts? fix what's causing it. And sometimes, as I said, it's as easy as really reevaluate your misconception. Like, it should be running under 5 milliseconds. Turned out that 9 times out of 10, it runs under 10. Well, where's the bar? If it's not, on paper as an SLA, it needs to run under 5, then who cares if it runs under 10? It's still good. Sometimes it's actually, keeping a paper trail. How many times did you get woken up? By what? Which system? Which app? Who's responsible for it? And don't shoot off a snarky email at 3:30. Hey, I fixed your shit, by the way. I can assure you that's going to generate goodwill all around. Like, no one's going to put sugar in your fuel tank or anything, It's going to be great. Works perfectly fine. Everyone loves snarks. No, what you do is you do the same thing sales is doing, you do the same thing marketing is doing, you do the same thing support is doing. You compile reports. You don't have to use Crystal reports or Excel or anything. You can just make a quick list of tickets and be like, okay, so we had 5 tickets when we had to restart that server. Turns out, you know what? No one actually used that server overnight because it's purely 9 to 5 service. Like, literally no one will use it. It's okay to not alert on it overnight. I know it hurts. I mean, I love uptime, but if no one using it and a server goes down, is it really down? That's the thing. And sometimes the key is to be like, all right, I know I'm not the product manager. I know we have a full load of feature, but right now, this is causing X times hour every week across 4 engineers. Engineers are being paid X for being on call, plus X for overtime. They're coming in late in the morning because no one likes to, come in after 2 hours of sleep. That's a monetary value, by the way, a very good one. And you can just bring that to product manager, being like, service X is keeping our engineers up. I would appreciate if you could prioritize fixing service X. And even better, you can even provide a bug report. We love bug reports. Bug reports are awesome. Another thing, since you've already talked to that product manager before to ask for their help, they'll be like, oh yeah, well, I know Francois. Yeah, he's in ops. He's a good guy. You should listen to him. If he says it's a problem for his team, then we should fix it. Because, you generated goodwill all around. And that's really the base of monitoring that cares, is you care about your user, you care about people that may be your user, but right now you work with them. You should care for everyone. And you talk to both internal and external stakeholders to get where you should be. So users don't catch you unaware, and so everyone in the company can pitch in so that no one catches you unaware. You're not alone in that job. I know we have that martyr hero things. I can fix this. Sometimes you can't, and it's okay to say, I don't know, please help. Thank you. Apparently I have 5 minutes. If you're tired of me speaking, I can just see myself off. Otherwise, you can ask questions. I'll see myself off.
All right, 2 quick sponsors, one of whom is a sheep in wolf's clothing. But Jason's going to pretend he's from Packet.
Probably isn't going to work. If it works. Sort of worked. All right. Yeah, look at that. It actually worked. I didn't think it worked because it told me, I actually just plugged in this multi-port thing for the first time. It's like, oh yeah, you're gonna install drivers. And oh, well, yeah, by the way, you gotta reboot. It's fine. So doing a quick step in for the folks at Packet, who are one of our sponsors. I actually did a while back. I don't know if anybody here reads my blog, probably not, but if you had and you're interested in graphite scaling, you might have seen this a while back, which was a blog post I did on some demonstrations on some numbers on and configuration examples on how you can scale graphite. And one of the really big things that you can do, and if you've used graphite before, this isn't probably news, is that you can run on SSDs. In this case particularly, NVMEs happen to be really, really fast. And so we did some crazy, ridiculous numbers that were all made possible thanks to the NVMEs on the packet systems, particularly the Type 3. As you can see here, 450,000 read IOPS per second. So yeah, suffice it to say, they're really fast and very inexpensive. So if you like DigitalOcean, and they're not one of our sponsors, so I have no problems comparing Packet favorably to DigitalOcean. Sorry, friends that work at DigitalOcean. They actually have a very nice deployment process. It's easy to get started, and it works really, really well. So especially if you, again, want to run graphite or any time series storage that needs fast disk. So thank you, and thanks to Packet.
It's a full service conference. We have one more sponsor, a talk, and then it's... Thank you. Our next sponsor is Braintree.
I love having a design team. Hi, my name is Matthew Duggan, and I'm an engineer from Braintree, an operations person, so not a salesperson, so be kind. I'm here to talk to you about payments processing. We recently partnered with Uber and Facebook to power the new opportunity inside the Facebook Messenger app to allow you to hail and pay for Uber rides inside of the app itself. We worked with Airbnb to keep their PCI compliance simple, while still allowing them to fully customize their checkout sites. And on a particularly cool project we worked on recently, we worked with Eventbrite to basically come up with an RFID wallet for customers to pay for things at live events. But it's not just these large corporations. We work with a lot of the folks who are here today. We try to work with corporations large and small to power their payments. We know that payments are not where you want your developers spending their time. It's not a useful use of your resources. So we really try to do everything we can to take the work out of that for you. We're the only platform that gives you access to over 192 million PayPal customers, Apple Pay, Venmo, Android Pay, credit and debit cards, and over 130 currencies around the world in one simple integration. Here are all of the features you need to run your business, we hope. If you need a feature, please let me know. But we know that a lot of the folks out there are already having existing working relationships with banks, so we offer two options. We can either provide you everything you need out of the gate to start processing credit cards the same day, or you can move your MID to us. This is your banking relationship. And we can integrate where you can use our API, but you keep the payments processor in the back end that you've always used. I know that PCI compliance sucks. Everyone hates it. It's a huge pain for you and your infrastructure. We take care of all of that for you, not just the technology, but we have partners that will provide you the certification that you need to demonstrate your SAQ compliance. One way that we do that is through our hosted fields. Hosted fields are small iframes embedded in your checkout page. This allows you to apply your CSS, your flow. Your customers don't know that they're interacting with us, but your SAQ compliance is still A. We know that checkout is one part of the flow, but it's not everything. The Braintree Vault allows you to store customer information, access those customers later, and charge their credit cards or payment methods at a later time. This opens up opportunities for custom recurring billing, metered billing, sort of whatever you can think of. I like to think that the API is pretty simple. You can integrate usually in a few minutes. If you need a little bit of help, our GitHub repo, Braintree, has sample integrations for almost all of the large sort of full stack platforms today. We also offer a sandbox environment with identical values to our production environment for build tests, developing, things of that nature. We offer client-side libraries for iOS, Android, and web. Server-side languages in the language of your choice within reason, no Erlang, but we try to hit most of the big ones. One feature that I'm particularly proud of is data portability. This means that if you are at an existing payments processor and you'd like to come over to Braintree, we will take your data from that payments processor if they'll export it, not all of them do, import them into our vault, and allow you to access those customers. If at a later date you are not satisfied with Braintree and you want to go somewhere else, we will export those customers for you, the raw PANs, transmit them securely to the new gateway, all free of charge whenever you want. One feature that we're particularly proud of is we are a part of the PayPal family along with Venmo. Venmo has done about $20 billion worth of payments in the last 12 months. We are the only integration that allows your customers to use Venmo as a way to pay your business. This is huge for younger customers, customers who are used to mobile first. And again, it's one integration. You check a checkbox, that option is available to you. We're a Chicago-based company. Our support team is based in Chicago. I started out 4 years ago on that support team. We work very closely with merchants large and small. We help you with your integration. We know that you don't have a lot of time to spend on this stuff, so we really do try to make it simple. We also have account managers who will walk you through things like accounting and reconciliation and making sure that you got paid. But part of that too is with the recent acquisition by us of PayPal, we have access to a huge library of payment resources that simply didn't exist before. PayPal is the largest payments gateway in the process in the game. They've been doing it for the longest. They have so much expertise, data centers, resources, etc. So we encourage you to rethink payments and to give Braintree a try. Thank you very much.
There's a thing there that says step. It's pretty scary. So we're running a little bit ahead of time, and I'm going to give myself a tiny reward. And I don't think Jason is looking, so shh. But in my day job, when I'm not Monitorama-ing, I'm the head of engineering at Simple. Simple is a bank, and we're based here in Portland, but about 40% of our engineers are somewhere else, distributed all across the US. We're also hiring, obviously. And if you want to work with me, or if you'd like to understand how banking can be better, hit me up on Slack or find me at the hike tonight, which may be someplace else in the Rose Garden, because it turns out there's a ton of construction happening there. So we may have to fail that over too. But I would like to work with you, so hit me up if you're curious. With that, we have one final brave speaker before lunch, and then you get to go eat. That speaker is Jan Ramin. Please welcome him to the stage.
All right. My name is Jan. I'll have a hi slide in a second, but I'm going to first show the title slide because that happens to come first. So consistency in, which is now observability of microservices at Lyft, or fighting entropy and hopefully delaying the heat death of the universe, or at least your microservices, or maybe your engineering staff. Instead, here's the hi slide. Currently engineering manager at Lyft, observability team. When I started, I was the only person on the observability team at Lyft because it just got created. Previously at Twitter, same exact thing. Deal with logging, time series databases, aggregator statistics, dashboards. We also do some performance profiling, do a bunch of low-level infrastructure. Before I started dealing with web services and on-call and operations, anything like that, I used to deal with embedded systems and trying to debug wireless sensor networks with tens of thousands of nodes. Run C, and then terrible software bugs show up. But C is still the best programming language. Totally should use it for everything. Thank you. So this talk's trying to cover approaches and techniques to avoid production incidents or almost production incidents or things falling over or oops, we messed this up. When you're dealing hundreds of microservices, this probably should be a dash of microservices, but there'll be 2 words today. Also, when your microservices are in a bunch of diverse teams, product teams, infrastructure teams, teams that this is the first time they've seen a computer, possibly. You never really know. Companies grow, things happen. So what are we trying to solve? So developers are on call with microservices, not operations, not DevOps, not the infrastructure is on call, although we are, or scaling operational mindfulness. This isn't unique for hundreds of microservices. It could happen one of 10. This could work well with monolith in many cases. The trick is people that understand operations, people that understand services, people that understand, oh, I can monitor this, or what is monitoring, or how do I write a log file, sometimes are in short supply. When you start having very small teams, 5 people, 10 people, you end up with a bunch of great software engineers. The odds of hitting an operations engineer sometimes is lower. So things happen. For example, I didn't realize it was just logging all weekends and generates, like, filled my disk and then crashed because it was just nothing but error logs where I couldn't even import a module. Or what is a log file? The other one is, like, I click production deploy and Jenkins told me everything's good and then close laptop, go home. And then everything's fire and where are you, what happened? There's also a opportunity for excellence there, as in, like, our deploy system says everything's great and then it just melts down. We can get into that in a bit. No one set up a PagerDuty rotation. Who to page? What is paging? Am I on call? What is on call? There's a checklist. We have a thing, if you're going to production, you should do these things. People finding the right checklist, finding the right version of the checklist, realizing there is a checklist, sometimes just doesn't happen. Something else we're trying to solve. We need alarms on thing X, whatever X is, database, service thing. Let's copy and paste them from my last service, and eventually you play the game of telephone. This is with Google Translate. It used to do a much worse job. I just tried doing this a couple days ago, and it mostly made sense. I had to go with 10 languages to even get something silly. The famous examples where you type in Lady Gaga into Google Translate, and now it pops Beyonce in a different language. Don't happen anymore. They fixed a lot of things. Good job, Google. We'll have to deal with that. Or I have no idea what's broken. Your rubber duck is actually broken, and you're talking to it, and it's broken. And how are you going to debug anything? So we routinely approach monitoring as operations. We know how to set up something. We know how to add a log file. We know how to grep and Splunk or other logging system, or we know how to look for a metric. We don't necessarily always think from it from end to end. How are we dealing with monitoring from the very beginning of a service life cycle to the very end? Use this picture here of a very old TV, point-to-point construction. Someone sat there and placing all the parts. It was probably built this way. Someone wrote it down, and now there's your runbook of how to build a TV. No one ever sat down and built a block diagram of what the TV should look like. Probably can't read that, but that's okay. It's a block diagram. Here's a module connects to this thing. Here's a speaker. Or monitoring. Here's where the stats come in. Here's what we're checking. Here's how my service works in flow. We really need to think about how to abstract and kind of modularize monitoring. How can we make it easier for people so you don't have to start from a blank slate literally every single time you do something. So some backstory. I will say Lyft does a number of good things in terms of how we set up deployments and operations. I used to have a before slide. It's kind of terrible. It was a monolith with PHP. We won't get into that. So about today, we have a lot of Python microservices. We have a legacy PHP monolith. We have some new Go microservices. We've spent the time for making each language actually supported, so they have a core base library. Sometimes there are people working on the base library. Sometimes it gets neglected for 6 months. It happens. We have hundreds of microservices. We also don't have a monorepo, so if you're ever thinking, do you need a monorepo? We actually have a monorepo called monorepo. It has profanity in it, and that's one message, and that's it. Sometimes services deploy 10 times a day, 20 times a day. It might be a little extreme. Sometimes never, like literally there's a microservice that doesn't run anywhere. I'm probably responsible for about half of those, but sometimes this last service deploy was 6 months ago, and it's great. It's a perfect service. Of course, that means it's running libraries from 6 months ago. If someone wanted to change monitoring, that was 6 months ago. Is that out of date? Doesn't have to be. We have a layer called base, creatively, which basically runs on every single AWS instance. We use AWS. We use masterless salt to actually set up the instances initially and do some management of that base layer. There's other things involving S3 and cron. I'm not going to really get into those. DevOps question mark. Teams are on call for their services. Like there's no on-call staff. There's no SREs embedded in teams. We hire people that understand operations, but we don't have the SRE role. The infrastructures team enables people. It doesn't operate things for you, unlike the classic way of, throw developer code over the wall. Starting off, we have system metrics and kind of the pipeline of how metrics work. Everyone talks about stats-D flow diagrams, so I'm going to talk about stats-D flow diagrams. Kind of have to do this in order to get metrics working. It's part of the consistency story. The goal is to make it easy to produce metrics everywhere safely. Like, you should be able to happily instrument your code, and it shouldn't take down the rest of the monitoring infrastructure. You want people to use it and not feel like, oh God, am I going to break this if I add this call here? As I said, big secret, use the stats-D protocol. That's the Node.js thing. We did at some point. I ripped that out as fast as possible. Comfortable compartmentalization. If it fits, I sits. So for metrics, it's kind of important if we can just say, like, what service is this? Where am I running? What's my node ID? Am I an application? Am I a worker node? Am I this? Am I that? There's a number of things that people mess up in their code. They have a wrong deploy. If you can get that right from the beginning by basically bundling metrics into the right bucket, we do that. I'll get to exactly how we do that, but we do that on every instance. It knows who it is. So what it's going to do, it's going to make sure it routes them and make sure it's going to enable the right thing. It's going to put it all into the same box for you. This is also an important part, but it seems a little obvious, but it didn't happen when I first was there. It was like, metrics show up. Things are called app. What is app? Who knows what app is? So our pipeline setup, it's a bunch of cascaded stats, daemons that talk. Receive UDP only, never send UDP. Please don't send UDP over the network. If you have buffers, manage it yourself, otherwise things get sad. 2 pieces of software, they're open source. They are very divergent forks. I apologize profusely. They're from other companies originally, but they've been hacked on. We're trying to actually build a Fusion product out of it. It's not ready yet. So that's really C daemon. It can basically take metrics in, it can do resampling, it can do aggregation on the fly, and it can write it to one more places and transform it in some way. StatSide is a stats-D aggregator, classically. It does approximate histograms, it does counters, it does gauges, it does other histograms, it does sets. Most people don't even use any of those features. Then we write to TSDB plural, we actually write to multiple. We do use Wavefront for a lot of the prime monitoring, but we have internal things. We have a few other outside data sets that get to places because they did X better. So we actually have a giant pile of regex to decide what goes where, which is also a bad idea, but we do that. So what do you get? So unlike a lot of systems that operate in the billions of metrics a second scale or minute scale, Twitter, so on. So we don't by default write things from every single host. Like if this host has 10 RPS, we probably don't store that it has 10 RPS. We just tell you your service, X, has 10,000 RPS. Maybe you want outliers, maybe not. You can get that data, but by default you don't have that data. It does control costs a lot. By being able to resample things that go upstream, we can also smash things back together, control the traffic. We don't have this that's the aggregator node that's just like 2 gigabytes a second in. We don't get those silly problems. We also do 60 seconds. Some people have 10, some have 60. What's the resolution you want? We pick 60. We used to have 10, now we went actually to 1. We realized 1 is a lot more useful than 10 for things that actually react really quickly. MongoDB might be one of those that needs 1. I won't comment on MongoDB, but we do it. We also flush consistently. So a lot of systems will just, every 60 seconds, whenever they're booted, whatever the timer thinks it is, they'll write. We always write top of the minute or top of the second. So your aggregates are completely aligned. You don't have a jitter of 2 minutes, which is less a problem than 10 seconds, but you have 20-second jitter. Little dig into stats relay. Config file, it's JSON, you can't comment in. I apologize, it was much easier to parse. As opposed to like libyaml, I hate YAML. Local stats, so I said we run StatSite on every single instance, so you get host stats out of it. Monitoring yourself, so we added some features that, hey, how's stats relay doing? Do you send it to the central aggregators? No, what if that broke? So we have a separate cluster that tells us how stats relay is doing across the fleet. And then send to central aggregation. In this case, we sample every 5 seconds. We also sample timers every 5 seconds. We limit up to 100,000 unique names emanating from this host in this example. We actually have a lot of custom metrics that flow out of our system. So 100,000 is not generous, really. We have some actually higher. They're extreme examples, but. So we have a lot of events. If we dealt with the raw event stream as a without sampling, it's terrible. We're not like this cat. Billions a second, we do aggregation. We only emit about 200,000 metrics a second that are fully aggregated. Like if you were to, as I said, we do it at the top of a minute, but then we back off randomly. It's not that much. It's not millions. It's not billions. We limit cardinality. And we have opt-in mechanisms for, hey, I want per host and per second data. And you can actually do that in the client library. You don't have to deploy a central config. You just add a flag saying, make this per host. And it shows up per host. System metrics, collect D. I have opinions about collect D. It's neutral face is a pretty good opinion about collect D. We have custom scripts that run. We have some bash functions. We've had Python code that famously called the bash functions to send metrics for some reason. We'll send them to local stats relay. That does all the forwarding and aggregation for us. So what do we get? System metrics. Those are good. Every metric reducer sandboxed, rate limited, monitored, no UDP spam. We've generally preferred LIFO queuing over everything. Stat side now does LIFO queues. I don't care what it was 10 minutes ago. If your queue's backed up, I want to know what it is now. If we lost it 10 minutes ago, great. That's fine. Not perfect, but I want it now, not, oh, we're processing the back queue of 3 hours. We'll be caught up to real time in 6 hours. I want the, like, this is now from Spaceballs, which I didn't put in, which I should have. Instrument the core libraries. So, as I said, we should instrument the core libraries. They're everywhere. People use them. They might be in really different versions, but at least we tried. Kind of the problem is developers add metrics after already broke ones. Usually like, oh, I should have checked that. I should have checked my RPS. Oh, I didn't catch the errors. I didn't realize it crashed. Adding metrics on like, this request was called. It's like people shouldn't have to do that. It's kind of silly. And people don't even think they should emit metrics to logs. This is a cheap hack. If you're in the Python world, do this. Now you emit metrics when you log, and you can even figure out what file it was from. If you just have a default logging handler and you just output statsd, it's like, oh, you're logging errors from somewhere. We don't know, but maybe we scope it, maybe we don't. Maybe they're errors, maybe they're criticals. We actually, if someone emits a critical or a library emits a critical, we just page somebody. Don't do that. It broke badly. You should fix that. We also instrument the RPC. This is, for us, done with Unicorn. I'll get to that in a second. We use a lot of Unicorn on the Python side. For the Go side, we have our own stack, so we instrument it there. Unicorn lets you do it with, once again, logging handlers. It doesn't understand metrics, but it understands logging. You can make one to the other without ever writing a log line. Blinker is a nice little library that lets you just like do multi-dispatch and filtering in events, and we output statsd. Getting into Unicorn, don't be afraid of monkey patching. Before we had a lot of rate limit controls on our central statsd, we've had to literally put blacklists into things that, because some bad library got deployed everywhere. Instead of trying to deploy 20 services, we just put it into unicorn.conf to not write that metric. And then it stopped writing and everything was happy. Spent a little CPU time, if check every single time, but then we deleted out of the library. Eventually, we actually put it into the core network layer so we didn't have to react and write things into Unicorn. It's also the worst, don't monkey patch, unless you really need it. But do if you want, don't, yeah, okay. We also have Envoy. You've probably heard the name before. When I started, we didn't have Envoy yet. It was in the formative stages. It definitely wasn't everywhere. So we're doing a lot of like instrument Unicorn, instrument this, and instrument PHP. Now every service talks to every service and actually most external services through Envoy. So that gives you the ability to, which is actually easier than it sounds. You can basically say, this is a proxy server. Go to host, set the host header saying host app name 2, and then route to localhost, whatever, app name 2, and off it goes. It figures it all out for you, does the retries, generates stats about it. You just have to tell what host, or how to find host name 2. There's a discovery service that literally builds on Dynamo, so it's even not consistent. It's fine. Use Redis. Doesn't really matter. It's a really simple service, like it's 100 lines of Python. Has failures, discovery, is the host performing badly, I'm going to eject it. It understands a bunch of things. Also generates copious stats. For most instances, Envoy is the #1 metric producer. Some services do way more because they instrument heavily. For a service that just like started, it's very simple. Envoy dominates by far. We also have some internal tools. We're way behind on the internal tools track, but we have some. This is InfraViz. Usually there's names around the circle. I just deleted them. It's not called Service X. I tried munging CSS, and this is what I got. But it also changes colors. You can go yellow, red, what goes to what, what's the traffic rate. Kind of a nice little tool. This is also not all of them. This is like what we call the golden path. It's services that are critical to ride availability. Like I can request Lyft ride, and then a driver shows up, and then you complete the ride, you get dropped off. That's the wheel that's required. And they all talk to each other in various ways. So it turns different colors sometimes. So what do we get out of that base layer? We haven't touched the application yet. We've just been hacking on like core libraries and everything. Get consistent measurement. We get consistent visibility. The metrics in Envoys are always named the same. The metrics in logging are always named the same. You can literally say, is this service logging too much? And you can find the dashboard. You can write a query for it without knowing anything else besides it's a Python service, not someone yelled in a Node.js service as a Python service, which just happened. That breaks it. But most of the time it works fine. You get point-to-point debugging. What calls X? Where's the problem? Envoy also adds tracing information. This talk doesn't particularly touch tracing, but tracing is a very powerful part of this. It's great for individual debugging. It's great for understanding flows. It's also probably eventually great for understanding long-term performance. For live monitoring, it's about the same. We also do some deploy time standards. Grab some water a sec. So what I mean by deploy time standards is, if you're deploying a service, we check a couple of things exist. It's part of the deploy process, the base make file. We do that with Orca. Orca is a salt module for orchestration. So basically, provisions everything in AWS, provisions everything for deploy, make sure service exists in PagerDuty, make sure the service is associated with an escalation policy. It doesn't check that anyone's actually on call for the escalation policy. They could. That hasn't been too much of a problem. People generally, oh, I do that, and I create, okay. So the schedule could be blank. It could never page anyone. We could check that later. Otherwise, you just can't deploy to production. Occasionally that breaks, and then you can't deploy to production anyway, but assume it works great. We also do application metrics. So the goal is do the right thing easily. This is not going to blow your mind, but there's a Python module. You can increment counters. We added the tag support, added the per host support. Everything will show up with your right service name. It will be called API. It'll be called my special service. The my prefix is literally what do you want to write. It'll always come from the right spot. You can always find it in metrics based on what it is. As I said, you want tags. We support point tags and statsd, not the dog statsd edition. We invented our own before I realized, oh, that has that too. So it's not like vendor compatible if you're interested in the vendor stack. Also does per host, which is our internal routing. We have Go Stats. It's a boring statsd library of local buffering for Go. It's open source. You can use it. It's not like, wow, this is the best library ever, but it works. We also don't discuss PHP, so we're going to skip that. So, gripes. Statsd calls are actually not that cheap. People like putting statsd calls of timers in their inner loops, and then they spend, why is my service spending 50% of the time in system? Because it's making a syscall for every single UDP packet it writes to localhost. Like the Python module has a little workaround for the .pipeline operator, which you can use. People roll it up manually. It's unfortunately an escape gap where like I want cheap, free debugging everywhere. Escape from that philosophy. So it's like, oh, that might cost performance. I have to make a decision. That's not what we want people to do. We want people to just instrument however they see fit, whatever makes sense for them. We're working a bit on that. We're trying to actually, libtlm is not open source, so we're looking at it. It's a native library to handle consistent instrumentation at Lyft. Actually just dumps metrics into shared memory. You can read them back out of shared memory. If you look at Envoy, that's actually what it does, so we're trying to branch out into all the different services. So we actually have agents that will just go read it out, and then so the overhead is really, really low. We don't have particles like Stripe does, or Like you have to decide, I'm emitting a log, I'm emitting a metric. Currently, we don't have any like wrapper around that system. All right, unified data. So we have lots of cron scripts in Grafana. Getting into multiple system syndrome. CloudWatch is the only source for some data. CloudWatch is also neutral face. Like for instance, DynamoDB data. Do you want that? Maybe 1 or 10 minutes later. Here, have some fun. What happened? I'll wait 10 minutes. And then also like if people actually had to look at the CloudWatch console, it's like, hold on, let me log in. Where's my MFA token? That doesn't work. Because I'm going to reset it. What's my password? I haven't logged into this in 6 months. Using different systems is distracting. You have to change context, you have to change tabs. What is it called? Where does it go? What do I name it? And it delays debugging, because do I trust that data? Is it represented the same? Like, CloudWatch loves making everything sums by default. So like the scale is very different. Like sum over 5 minutes. So I want the average over 5 minutes to match the other chart. And then it's like, wow, this is like 10 times that, or 60 times that. Less tools. So less tools for triage are better. Context switching is expensive. The goal is to put everything onto one dashboard, or at least one click into another system if you have to have another system. Like Grafana can aggregate logs, but it's not a good log structure. So eventually you want to get to the logs, so maybe make it one click away. Realize there are different ways to think about it, tracing the same kind of thing. So how do we do that? We either federate, so like, can we install a Grafana plugin and just read this? Great. Or what we do a lot of is have scripts that read from A and write to B. So we pay n times for a TSDB cost, which is not fantastic, but it does make it simpler. The query language suddenly is the same. The other system works the same. The naming will be different, but you can usually map it, and if you have like a good naming philosophy of how to name metrics, this is a good way to get there. Next up, I'm going to talk about a service we call dashboards.get. Lack of creator name, it's not called .cat, although it could be, that'd be kind of neat. So dashboards.get is our central monitoring and alarm hub. It's a monorepo. This is not the one for Profanity Unit. It ties in for salt infrastructure. It's literally a salt state. It deploys like a service. Literally, you go through Jenkins, I'm deploying dashboards, and off it goes. You get dashboards. If you wanted to locally test something, it was staging Grafana. By default, it publishes to Grafana, publishes to the Wavefront. It could publish to Kavana, it doesn't right now. It'll publish to other services. It'll create the dashboard, it'll make sure it exists, make sure it's named right, it has a bunch of data in it. And the most important part, every service gets a default dashboard with base alarms. It sounds simple, but that doesn't happen in a lot of places. Literally, there's a file that says, what is a service? And is it deployable at Lyft? Or it's now a bunch of files that can merge into one. Each repo has one. And then there's a for loop that runs over it and generates a dashboard for it, which is pretty exciting. And there's a bunch of extra stuff you can do it. Do I have extra services? Do I have to customize it? You can totally do that. Like by default, we assume your service, you get network, calls you in and out, and you log things. Then you have a machine it runs on, you have some disk, you have some CPU, and you have an error rate, you have a latency contract, SLA. We have some defaults, they're pretty generous, 98% or something for SLA, for success rate. If you have like 10 RPS as a brand new service, one error, you're already out of that, so it doesn't make sense to have really tight bounds for brand new things. Hopefully people change them as they actually go through like a production readiness review. As I said, we can also define custom rows and targets. You can define like, oh, I'm using Redis, I'm using DynamoDB, I'm using SQS. And the best part is you never had to understand how to monitor SQS, how SQS really works, what's important about SQS monitoring. What metric do I check for error rate? What metric do I check for success rate? Eventually, we are actually getting to a world where in order to talk to another service, you have to tell Envoy I'm talking to the other service, and then we can actually read that file and then make sure you have it. So you can't even talk to it if it's not monitored. So like, what does that look like for our services? It's YAML. I really, really hate YAML. It's even worse when you add a templating language on top of YAML, but some people like that. And salt works with YAML, so it's kind of what we use. What's my error rate instead of success rate? Someone wrote it backwards initially, who stuck with it. Do I monitor file descriptor usage? Happens, you leak. We're actually making that turn on by default now for a lot of things. Autoscope groups. Am I hot? Am I not hot? Redis, DynamoDB, SQS, a bunch of internal services. Prepend rows, you can just put your own stuff on top. Like I have an important business metric I want to track first. Shows up the top row. Most important part is infrastructure teams or teams that run the thing you're dependent on, write the monitoring for it. You don't have, not everyone has to understand how X works. Someone just has to understand how DynamoDB works, and they write the modules for you, and then you have monitoring for DynamoDB. It gives you a consistent look and feel. Every dashboard at least has a section that looks general. If it doesn't apply, you can turn it off, so you see missing rows. It's a Git repo, so now you can have code review for dashboards and alarms. Kind of people generate things in the UI all the time, ship it, and then they go home. Code review is good, we should do more of it. You can also use grep. It's very handy for finding something, as opposed to like, do I download all the JSON from Grafana and then grep through it? I don't know. We also make sure alarms exist on dashboards. Like we don't use Grafana alarms. It's right now mostly waypoint alarms. But if there's a visualization, it can have an alarm. That's pretty novel because the thing you're alarming on, you probably also want to see it other times when it's not alarming. There's less copy and paste. We can globally refactor. We've done this a lot. You know, do we change X to Y? Or if we've messed up that alarm for DynamoDB because a thing changed. Change one line, redeploy, everyone has a new updated DynamoDB alarm. 10 minutes later, actually probably a lot longer than 10 minutes because the deploy is really slow. But please wait for it and speed up your API. So you can also customize alarms like, oh, 2 minutes is too tight, I want a 10, change it to 10. Free alarm. Sometimes the alarms are really hard to write, let's get you out of that. We have a query parser, we can rewrite things. We can transform queries into alternate forms. We generate like a deploy dashboard even for you, which compares two things from the original dashboard you defined. It's all machine translated. Automatic staging. We have a linter that says don't ever use this function because it's stupid and they should remove it from the query language. People have shot themselves in the foot with it multiple times. Like this is a quick example of a deploy dashboard which looks just like the original. Like people wrote those charts and now it looks like the canary or compares the two. What kind of sucks about it? Grafana is a UI builder. People like using the UI builder because it's really hard to figure out what otherwise a setting is called in the Grafana JSON language. Because our dashboard module, once you get to customization, is literally just like, what is the field called in JSON? And they have to write it in this. It's terrible. We ask people to commit change and YAML to a repo to get Grafana to work. So we have a managed dashboard script. What else sucks? Monorepo, it's a great way to get it there, but it's a single deploy. People put breaking changes in it. They didn't realize it broke everything else's. It's not great. To go into a little bit of what Amy said this morning, some of the query languages, alarming, user experience showing that are really actually just too difficult. And our choice has been like, people don't have to write this. We'll just most of the time cover the bases well enough that you don't ever have to learn this. If you get into specialty stuff, you should probably start looking at it. But we don't want people that are not experts to suddenly have to learn what the heck a query language is, what the time series is named, so on and so forth. I'm almost done, so. We do enrichment. So what we do is like, oh, we got a PagerDuty alarm. Like, great. Most services integrate a PagerDuty and tell you you're alarm fire, and then they give you a link to the thing. But then it's like, oh, what dashboard was it on? Is there a runbook? Is there a Kibana search I can do that also shows me the same kind of information? We put it into one service, we figure out, oh, what can we else tag onto this alarm that could be relevant? Traces, runbooks, so on and so forth. We do a little interlude on trust and self-defense. Will the dashboard load? Can I trust the data? Can I take the service down? Beautiful picture. We have a page. Is observability running? Of course, you know, DynamoDB is not running. This one updates a few hours later. We've had limits. It aggregates. We've had people put counters, memory addresses in their metrics. Happens all the damn time. Breaks things, so now we don't break. It's part of building trust is I can mess up and not bring everyone else down. We're also not done yet. This is like the beginning of the journey. Is anything ever really done? We want to build new UIs. We want to figure out how to make incident workflow better. But we hope the present is a good place to be. Or is it reality? Thanks.
So you ran exactly 30 minutes, but we're 5 minutes ahead.
Excellent.
So if there's any questions? I think everyone's hungry.
Going twice? All right.
All right. Awesome. Thank you very much. Appreciate it. Hello. All right. So we're doing good on time. We're actually 5 minutes ahead of our typically scheduled break for lunch. So yeah, everybody enjoy good lunch. Please try to be. Talks start at 2:30. We have another afternoon full of awesome talks. And sorry, quick round of applause for everybody this morning. Those were fantastic talks. So good stuff. All right. See you back here at 2:30. Thank you.
Welcome back. Who had a disappointing lunch? Awesome. Great. Congratulations. So we have a few more speakers, a few more sponsors, and then we are done with this thing. Okay, we added another day. Yeah, nope. Let's get going. We have a great afternoon of speakers ahead of us. I would like you to make a warm round of applause for our first speaker, Ian.
How's everybody doing? Have a good lunch? I guess that question was already asked, so thanks for joining me and coming back from lunch soon. I know there's not a lot of time. So I'm Ian Bennett. I'm a software engineer on Twitter's observability team. I think it's worth mentioning how great all of the other speakers have been during this conference, and give everybody a round of applause that's set this up. This has been awesome. And if you're like me, you've probably been soaking up all of the talks like a sponge, and at this point, your brain is probably nearing capacity. So try to make this a little bit of fun. Hopefully this is interesting. And the title of this talk is Critical to COM, Debugging Distributed Systems. I think this week has sort of been described as critical to COM with the power outages and all of the other crazy stuff that's going on. I think today is a pretty chill day. So that's what we're going to talk about. We're going to talk about some of the experiences that I've had since joining Twitter's observability team, some of the stuff that's resulted in us getting paged, and not knowing necessarily what the next steps were. There wasn't a clear way to resolve those issues. And to set some context, our team's objective is to allow engineers to gain insights into and optimize their services in real time. From metrics collection and querying to alerting and visualization. We deal with an interesting scale problem in that we're currently handling over 3 billion unique metric writes per minute. And that was at one time up around 4.3 billion. So let's dive into this. We're going to start off with a case study, and this is called Diving Instances, and it's a simple fix. So we've got the stateless service that's running in Aurora. If you're not familiar, Aurora is a Mesos framework for long-running services and cron jobs. We looked at our service dashboards, and it was telling us that the host uptime was averaging less than an hour. This was due to high garbage collection overhead, and Aurora was failing the health checks due to these long GC pauses. So what we did was we attached a profiler to an instance, we took some CPU samples, and that told us, if you have never seen YourKit, this is a YourKit screenshot. I'm a big fan if you're using the JVM for a profiler. And this stack trace here is just determining the hash bucket for a Scala hash try map key. So why is that a problem? And what can we do to solve it? If you're not familiar with Scala, the concept of a case class is different from a standard class in that it auto-generates some things for you and exposes some handy language features like being able to decompose things through pattern matching. The caveats to that are that we were using this case class as the key to the map. And Scala's case class auto-generates a hash code for you. If you've ever done that over collections, what ends up happening is it hashes over every element in every collection in the fields that you define within that case class. So this was going through all of the collections that were defined as fields and burning up CPU and causing tons of GC. And we provided a custom hash code, deployed that, measured and validated that it was fixed. So if you look at this, you can see all of these hosts just falling over, and then we deploy the fix, and they're up more consistently. And this is over the course of a little over a month. Some of those that are still falling over is stuff that we're working on right now. So since we got through a quick case study, I'll go through the methodology that I like to use to solve these problems. So the first thing to do is to measure something, because if you can't measure something, you can't quantify it, and you don't know if you're actually impacting it when you make changes. So first measure, then analyze the results of that measurement, make an adjustment, and then verify that the adjustment that you made is pushing you towards the goal that you want. And I have a background in performance optimization. I like to use the term peeling the onion when you're trying to dig into problems. So this is what I like to consider the onion of determining how to continue to move forward with solving these issues. So the outer layer of the onion, you start outside and work in. The outer layer of the onion is metrics. And for us at Twitter, those things are dashboards and Viz and our Mon 2.0 service where we have monitoring and alerting set up. Once you understand the metrics, you get to the point of trying to do tuning. Tuning is cheap. Tuning are things like changing application parameters, JVM settings like your heap settings and garbage collection, the style of garbage collection that you're using, your container settings, whether you're changing CPU allocations or memory settings, and then operating system kernel level tunings you can get into. If those things are cheap and easy, do those. Once you get past that point where you can't fix it, move down to tracing and logs. And in Twitter, we use Zipkin for our distributed services tracing, and we use Loglens for our log aggregation, which is pretty similar to Logstash. I'm sure most of you have used that. On the profiling side, these are low-level OS tools or JVM profilers like that URKit snapshot that I showed you. And then if you can't figure out what you're doing from a profiling perspective, if there's not enough visibility into that, you get into custom instrumentation or code changes. And typically, like profiling, if you find the issue, you're probably going to have to make a code change in order to resolve it. So they sort of work hand in hand. And based on the fact that the other speakers have done such a great job of going through the top 3 layers of this onion, I'm going to spend a little bit more time talking about profiling, custom instrumentation, or code change. So this is when to peel the onion. So we've got this methodology and we've got the onion, so we understand these layers and what to do. The concept is that you should make a single change at your current layer and continue to repeat the process of looking through this information and trying to move towards a target. You want to avoid the urge to make too many changes at once, and I know I've done this a few times where I'll go through and I take a profile and I say, these are the top 3 things that are wrong. Let me go and change all of those 3 things. It's a really bad practice to get into, and it's going to cause you a lot of trouble. So you need to be able to measure the positive and negative impact of that single change that you're making and verify that you also haven't changed the behavior of your system, that your fix was something that actually improved performance and didn't break your functionality. And then you also need to remember to re-rank and prioritize, because you could uncover bottlenecks that you didn't see the last time you took measurements, and you may not have enough information to actually make that next change. So at that point, that's when you peel to the next layer of the onion. So talking about profiling for a second, these things make up your performance. CPU, memory, and I/O sort of battle each other to determine what your application is going to be able to output. From a CPU perspective, profiling would be like looking at CPU samples, stack traces, doing tracing profiling, doing lock weight analysis. From the memory side, this for Java would be static heap analysis or like garbage allocation. And then on the I/O side, this is network and disk. And Julia's talk was much better intro at these things than I'd be able to give in this amount of time. So luckily, I don't have to do that now, and I can skip into a little bit more complicated stuff. So that was profiling for a single thing, and now we're looking at it from a distributed perspective where all of these little things, these funnels, are your service instances. So as Ben showed yesterday, you want to look at the worst offenders and figure out where those things are. Zipkin should be pretty decent at figuring out what part of your surface is causing the largest problem. And basically, we're just trying to isolate out bad actors and look at that one first. And that would be that one. So this is the one place that should get the most of our attention until that's not the largest offender anymore. So common issues that I see are things to do with logging. And this is people not understanding our logging framework. I'll get into that a little bit more in a minute. On the Java side, this is auto-boxing. This is things like using collections or maps that contain primitive types. They have to be boxed. For an example, this would be integer versus lowercase int. There are caching and memoization issues, which you'll see some of that too. Concurrency issues, which you'll also see some of. And expensive RPC calls. And this is things like thrift messages that are using structures that are inefficient for what you're trying to do, and then they cause an impact not only over your network, but they're going to cause an impact on your application too, because you have to deal with serializing, deserializing, all those things. So quick performance pro tip, if you do go into making performance optimizations, keep your code abstraction sane. Your performance fixes should be as isolated as possible, and you don't want to expose those pain points to your customers. The reason why. Your bitmap exclusive or bit shifting super efficient string deduplicating object pulling concurrent set is awesome. But your consumers shouldn't need to know like the underlying algorithm for that thing, and exposing that to them is just going to make things worse. This code becomes very brittle and hard to work around. Reason for this is that your micro optimization can also become obsolete. There are things like new library comes out, and that performance optimization, if it didn't make it upstream in this open source library that you're using, someone else did something better. Now you have to make all those changes in all these different places. You got compiler improvements that, for example, if you're using the multiply sign versus bit shifting, if the compiler optimizes that, it might actually be faster to go back to using the multiply sign versus doing bit shifts if you're trying to micro-optimize that. And then usage patterns for the application change, so what you spend a lot of time doing there, you're gonna have to do it again. The other problem with that is uncaught bugs. You might not realize something even if you have passing tests and you've got something deployed out into production and it's working great for a while, and then you realize that there's some functional issue that was caused by your performance change. You're going to have to make changes in all those places again too. Great. So fire, you've got critical issues, your pager's going off constantly. So what to do there? Stick to the methodology that I listed out. Don't panic, don't create more problems by skipping steps or guessing. Your gut can and will be wrong about the thing that you want to change. You're probably going to be tired, especially if you're getting paged at 3 or 4 in the morning. You're going to be frustrated because who wants to deal with PagerDuty alerts going off anyway? And you need to spend days iterating on changes to remove bottlenecks. Like, this might be something that takes weeks. So having a methodology where you're tired, you're going to have to work through this stuff, it's just going to save you pain. So let it guide you to a solution and reduce stress. So we're going to look at another case study. This one is heavy garbage collection, and we can't tune our way out of this one. So we've got this stateless service that's running on bare metal. It's got high CPU, excessive GC, and low throughput. We attached a profiler to the service, and we enabled some object allocation recording, and we saw that string format calls were causing excessive allocations. So let's look under the covers at what string format does on the JVM. Okay, so this is just defining some metric names. And we've got Manhattan front-end app ID, %s reads. And all we really want to do is replace what that %s is, because we have like a couple different things that we're tracking with our metrics. This is a pretty bad pattern for metrics collection in general, but it's necessary in this case. So what's happening here is they're trying to create or get this metric if it's already been created. And then we're doing a string format call with that format, and we're passing in whatever that thing is that's supposed to be replaced. That's the fully qualified metric ID. So this is pretty bad if you look at this. Basically what's happening is that under the covers for string format, Every time that format is called, it's compiling a regular expression, doing pattern matching just to replace that one value. And if anybody's worked with the JVM or practically any language, if you're dealing with regular expressions, it's going to be extremely expensive. So the solution to this is to change this so that we're not using regexes. We can just concatenate the string when necessary. We know the things that make up the metric ID that we're trying to use, and all we're doing is going to a cache and passing in the contents of what would make up that metric ID. If it's not in the cache, we concatenate it. Otherwise, we get it, and then we increment the metric. So that helped, but it didn't fix the issue that we were seeing. Performance issue wasn't resolved, and there was something else that was lurking behind the string format. I had to remove some of this for legal reasons. So that's my cat, one of my cats. So don't mind any of that. Underneath is what's important. This request stats initialization is happening tons and tons of times. And this is eagerly initializing a bunch of collections. So analyzing that code found that the many sub-collections that were being eagerly initialized weren't actually part of like the typical request response sequence. It was only a small fraction of them that were actually used during one of those. So the solution to this was to lazy initialize them instead and basically use immutable empty collections that the other code that exists that depended on the stuff didn't break. And then only on the first mutation did we actually initialize that collection. And then applying the two fixes for the string format and the lazy initialization actually increased the capacity of our distributed key value store significantly, which is good because our observability stack runs on top of that. So this is going to be another fun one. Iterating on this, we're looking at logging. Know your logger. So this is a method that's got a log trace, and we've got some string. We talked about string format, and there's some other stuff going on. Does anyone in the crowd want to take a guess, like what's wrong with this? No?
It'll always format it even if you're like not actually going to the trace level.
This is true. And what's extra wrong with that is we have no idea what entity and at.toString, how expensive those things are. At was actually like a massive collection, and it required going over the collection to generate the toString. So every time we were hitting this method, it was just exploding memory to do a trace call that the logger was going to ignore because trace isn't turned on in production. And apparently it removed one of my slides. So know your logging framework. Yeah, the fix to that is to not do that. Essentially, remove the format, there's a comma, use entity, and don't do toString unless you need to. Let your logging framework take care of that for you. Okay. So we're going to get into this crazy case study. And as a side note, Jan, who was the previous speaker, actually worked on the service that I was talking about here. And we talked about it a little bit at the speaker's dinner, and he apologized profusely for this code. But Jan, this isn't your fault. The code that I'm going to share doesn't have to do with what he did, and even if it did, it's a blameless postmortem. So, Nuthatch is our temporal indexing service, and the logging fix that we just went over was actually part of trying to debug an issue with this service. The success rate was plummeting between 9 a.m. and 5 p.m. Pacific time, except during the lunch hour. So this is a little bit strange. And this is a chart of our success rate, and you can see this actually took us days to debug this issue. And you can see at lunchtime, success rate goes back up, which is really strange. Why is this happening? So in order to solve this, we have to use our toolbox. We have dashboards. They show us that GC spirals are out of control. Our system memory usage is nearing 100%. These are static hosts. This is a stateful service because it's an indexing service. We can't increase our heat because we don't have any memory to, and we can't do some tuning that would easily resolve this. So we narrowed down some specific hosts with the worst case issues. We pulled logs. There wasn't enough information in the logs. We attached a profiler. We pinpointed some code using CPU profiling and allocation profiling. We even took some heap dumps and compared some snapshots. We put numerous fixes in some canary instances to try to see if this would help us with our issue, but it wasn't enough. So we need more context. Like I said, Zipkin, it can point you to the thing that's having an issue, but it doesn't tell you anything about what's going on inside that thing. Context is really important, and the logging that we had there also needed to be bolstered because there wasn't enough information in the logs for us to determine what was happening. And if any of you have ever used Finagle, which is part of the Twitter stack, I really like the concept behind it because it tries to make you treat your service as a function, and you have the ability to just easily create filters in front of your service to do filtery things. So what we did was we created a low overhead filter that tracked the top N worst offenders, and we were able to inject some context into that, like what was the request that was coming into the service, how long did this thing take, what were the other requests during this time period. We opened up an HTTP endpoint, and so we were able to connect to that endpoint and grab these stats as necessary and just let them accumulate over time. And we found the culprit. And when we applied the fix, our success rate went back up to about 100% pretty consistently. And before that, we were at 800,000 failures per hour that were going through our index service, and then back down to 0. So the fun part about this is what was actually causing the issue. So we had this stateless service that was increasing its number of instances and its number of metrics. And these things were being indexed, which is fine. For the most part, that wouldn't cause any issues. One developer had their dashboard open on their desktop. And this dashboard had a regex match against some metrics. They hadn't changed anything. We hadn't deployed a new instance of the service in a long time. There was nothing that had changed from a code perspective. Just more instances, more metrics, more expensive lookups. So our solution was, since we added in this instrumentation, we figured out which service that was responsible. We went down to the developer's desk and we asked them if they could close this dashboard for a few minutes while we watched our success rate. And it went back up to 100% when they closed their dashboard. So this isn't really an acceptable solution, and something else was wrong. The code was reviewed and tested. We actually had a cache in place that improved things in the past, and this really shouldn't have been an issue. This shouldn't have been a performance problem. This should never have caused any customer impact. So this is some code that we had in that service. And what this is doing is a cache lookup. And we've mentioned that observability and having metrics to track your application is a great thing to do. So that's what's happening here, is we're going to the cache, and if something is in the cache, we're incrementing a hit counter and returning that value. Otherwise, we're incrementing the miss counter, we're going to the service to do this expensive operation. If it has an empty result, we're incrementing a counter. We're putting that thing in the cache, and then we're returning the results. So that call right there to the service before it puts the thing in the cache, it's not a blocking request. So that's actually like this, where you have tons and tons of GET requests that are coming in. They're looking up the same key, and all of these things are processing and processing and processing. So the first insert would actually happen at that gray line. So the first get that actually pulls out of the cache is at the bottom of that gray line. And this was causing the GC spirals. It had just gotten so out of control that the processing and the cache never got to the point where it could catch up to this thing that was going on. So the solution is to just go to the cache for everything and deal with incrementing counters and stuff on the cache object itself. All of this stuff is non-blocking, and it does the same thing. So that looks sort of like this, where everything is going, grabbing that value, and it's waiting until it's available. So we rolled out that fix, and you can see here, we were sitting pretty close to 100% memory until that was rolled out, and then we got 30% more headroom, and the service has been stable since. So we were pretty calm and able to sleep then. So now that we're in a happy place, it's a moment for us to reflect on some of the stuff that I went over here. What can we do to make each other's lives easier going forward and help each other not cause these issues? So we should be able to gain some insights from looking at each of the layers of the onion that I had shown you. And these things should allow for discovery, right? We've got dashboards and we have metrics. We've got logs. All of these things aren't really connected to each other, and there's a lot of contextual information that's lost. And a lot of the speakers this week have been talking about this. This is something where, like in an ideal solution, we should be able to go from the outer layer of that onion to the inner layer of that onion and back out and be able to see insights into what our applications are actually doing and what the health of our services is in long term. And this is a pretty wide open area. And I think if you're interested in this sort of thing, you should probably come work with me at Twitter because I'd love to spend more time working on this. So yeah, there are a couple other things. If you have any questions about this, if you want to talk about profilers or any other like metricsy related things, feel free to reach out to me on my Slack channel or Twitter. If you go on my Twitter, I'm going to do something else right now. I think it's been great that you guys came in here for this talk. But what I'm going to do is I'm going to post out this poll, and I'm interested in seeing your input on this. A lot of the stuff that's been talked about this week are things that we have sort of solved at scale at Twitter already, and we're just holding on to them. So I'm interested if you guys would like for us to potentially open source our observability stack or offer it as a hosted solution or open source and host, or just keep it to ourselves because you don't care. So I'm posting this right now, and you guys could feel free to give your feedback on that, and thank you for everything.
I think that is a legally binding poll that Jack will have to obey the results of, I assume. All right, we have two quick sponsors that we would like to thank. First up is Select Star.
Hey guys, I've got pictures and lines, so I hope you're excited. I know, I haven't seen any of those today. They're not that good. All right, switch this. There you can see it all. Okay, so what is Select Star? First of all, I'm Zach from Select Star, and that's pretty much it. It's database visibility and stuff. So things like performance and health, availability, but we also pull back a lot of like configurations, properties, versions of your databases as well. So this is what I mean when I say databases. This is the things that we kind of support. So relational, NoSQL, cloud only. And then we don't really see that as being just enough. We also pull back infrastructure. So what I mean by this is we're not giving you a dashboard of every EC2 box that you've got with all the CPU lined up. You're getting more along lines of like, think about Aurora. Aurora, you have to pull the metrics out of the database itself, look at those, but you also need to connect to Amazon's API and then put those two things together to get a full picture of what's actually going on. So you can do the same thing for like Postgres CC2 or MS SQL VMware. So what does that actually look like in the product? We kind of have this breadth then depth approach. So these are a bunch of overview things, and we kind of see infrastructure as providing an additional layer of context so we can actually make good decisions about what we're going to investigate and what we're going to do. So where does infrastructure show up in the UI? A little bit of everywhere. And in particular, I'm going to go through some examples where we're using things like configuration data and properties to just do some cool stuff, and then I'll go into the other side of it, which is how it helps us identify issues faster. So in this particular case, this database isn't configured correctly. So we're kind of notifying you that that's wrong. So it's like code climate for database kind of checks. In this case, the database is over-provisioned, so it's cost savings. I don't particularly care about cost, but my boss does. So it's kind of always cool when I can down a resource in the cloud, save a few bucks. And then this one for MySQL, we'll talk about a little bit more about this. And in particular, there's the same kind of things we saw before. There's like AWS checks, RDS, things that you're kind of learning. But there's also a Band-Aid check. So if you think about when you have a slow query or some performance issue in the middle of the night, you end up spending a lot of time doing random things. In this particular case, there's an unused index. We probably put in that point in time. But we never went back and cleaned it up. So that's nice. So the other piece of it is, how does it help us identify issues? So yesterday I was preparing for this. I was like, you know what, I'll make a slide deck rather than do demos because who knows what's going to happen. And I was looking at this database and I was like, oh crap, what's actually going on? It's actually went down. And when I was looking at it, I was like, okay, well I have two main areas I can go into. I could go into the queries page. So each of these components is at the breadth level. And for any one of these pieces, we can go into it and get a more comprehensive page about that topic. So if I went into queries, it would give me every single query that's been executing on the database. I could click on any single one to get the full query text, that sort of thing. Connections, I can figure out everyone that's connected to the database. But I have this decision point now where I'm going to essentially go into depth, and I need to figure out which one I'm going to go to solve this issue. So it could be a messed up query, or it could be a connection issue. Well, that's where context is really helpful. So here, all the RDS information for this database is also propagated up. I could go in there, I could look at the configuration, I could look at the metrics. But even at this top layer, just gives me enough information to know network hasn't changed. And like CPU, like I'm not even using any CPU. So I've maxed out my connections, but like I'm not using anything, like what the hell's going on? It seems pretty obvious that there's something connecting to it. It's not actually relinquishing those requests. So where I'm going to go next is I would go into connections. And that's actually what it was. Someone wrote a script that they thought would disconnect, and it didn't, and it kept connecting. So it was a pretty easy fix, but this is an example of how context is really helpful for database information and monitoring. So that's all I really have. I didn't really go into any of the deep dive pages, so if you guys want to see actually what we pull back for, like every single query, the analytics there, we do a bunch of other things for formulaic, checks against your databases, let me know. So thanks. Enjoy the rest of the week.
And our final actually, this is our final sponsor. Yeah. Jeez. Our final sponsor is Sysdig.
Hello, everyone. There we go. Okay, so before starting, can you read what the dragon is saying in the back? Can you? Cool, perfect. Okay. Hi everyone, my name is Gianluca. I work at Sysdig, where we build monitoring and troubleshooting tools, and I want to spend just a couple minutes telling you about some of them. So, it all starts with the system calls. If you've seen the great talk that Julia gave on Monday, you should already realize by this time that being able to understand system calls literally gives you superpowers, because you'll be able to tell a story about your applications even without knowing how to read the code inside them. That's really that easy. So at SysDig we started to say, okay, let's build a troubleshooting tool that is based on system call analysis. So we did it. We came up with SysDig. SysDig is a troubleshooting tool that is fully open source and shows you an output that is similar to strace. The difference being that SysDig has a very, very low overhead, so you can use it in production. You're actually encouraged to use it in production. So I can do with SysDig something like, okay, show me just the system calls that my production database is doing. And this will show me just the system call that MySQL is doing. And then we have a powerful filtering engine on top of it so that I can not only filter by process names and things like that, but say that I'm just looking for a specific problem and maybe I'm looking at the system calls related to network activity. So I can use a filter such as file descriptor port 80. And this will show me all the system calls that every process the system is doing related to port 80, to a network connection on port 80. In this case, you can see that this is a ping pong between curl and Apache. And you can also see the payload. So something that you can do, you can treat the system call troubleshooting like as a grep for your entire I/O. So I can do event.type.buffer contains get. And then let me format it a little bit better. This will show me the individual HTTP requests that my processes are doing, even if they are inside the containers. And so that's the beauty of doing system call-based troubleshooting. But then we said, okay, with system calls, we can not only use them for doing troubleshooting, they tell such a good story that we can also use them for an audit trail of the system. So look at this. Last year, we came up with SysDig Falco. It's another open source project that we have, and it's a behavioral activity monitor based on system calls. So once you run it, Falco will stay there very quiet in the top screen, and then I can run a simple Docker container. For example, let's run it a curl from a curl image, and in this one I can do curl google.com and everything works fine, right? What happens if we start getting a little bit bad and my processes start reading files that they are not supposed to, right? For example, etc shadow, that's typically a bad file that a normal process should not read under Linux. And there we go. Since my auditing system is looking at things from the system call point of view and say, hey, someone inside this container opened the file etc shadow and the program was cat. So it alerts me whenever these sort of things happen. And another thing that usually happens when your system gets, for example, compromised is that system binaries are replaced with copies that try to do malicious things. For example, don't do this at home, but let's try to replace ls with curl. So we are making a big mess. And we immediately get a new alert that it says, warning, someone opened bin ls for writing. And you also get the container and everything like that. And now, of course, if I type ls, I get curl, so as I get confused, but let's do lsgoogle.com, and now we'll see that Falco recognizes, hey, someone, ls, started doing network activity. ls is not supposed to be doing network activity at all. And I not only get my behavioral system not only tell me that ls is doing network activity, but it also tells me the endpoint. In this case, we can see port 53 for the DNS, then an IPv6 address on port 80, and another IPv4 address on port 80. So these are the google.com web servers. And this is all based on a very customizable rule-based language that you can use. So system calls are really great. And so we have covered troubleshooting and auditing. The third one is monitoring. So we said, okay, let's pick all the system calls and let's pipe them into a centralized monitoring tool. And we came up with SysDig Monitor. So SysDig Monitor is an infrastructure monitoring tool that has all the things that you would expect. So in this case, I have an infrastructure that is reporting with a bunch of containers. And just by looking at the system calls, I can get pretty good level of system metrics that, damn it. Okay. Yeah, so I have a good amount of system metrics, and then you can get also very creative. So for example, just by looking at the system calls that all the processes are doing, you can look at the topological map of your system, and if I do something like this, I'm able to dig into how my application, which in this case are a bunch of containers running on Kubernetes, how they are talking to each other. And this is not just by looking like a network packets, we are really correlating processes between processes. So by looking at the connect and accept and the read and the write at the system call level. And then of course we have STATS integration, all the other things that you would expect from a modern monitoring tool. So gist of it, go check it out. A lot of stuff is open source and system calls are great. Use them for your troubleshooting experiences. Thank you very much.
I used a system call this morning. Cool. So before we bring out the next speaker, first, if you're sitting over there, can you sit over here? And if you're sitting in here, can you kind of move in so that they can sit with you? And while they do that, I'm concerned that you all are asleep. And I understand why that may be, but I'm not going to bring out Paul unless you show me you're awake. So I'm going to, okay, you're awake, thank you. So we're going to have to do some crowd participation, unfortunately. Not that. What I'm going to ask you to do is say, hey, Paul. Hey, Paul. No. You're too awake. At the same time together. And that will show Paul that you're ready for Paul to come out. All right? So I'll go 1, 2, 3, and then you'll say, hey, Paul. And then if it's good enough, you'll get to hear from Paul. And then we'll do a break, and you can do whatever you want during that. Sound good? So 1, 2, 3. Hey, Paul. Okay, cool. Come on out, Paul.
Can you hear me? Yes, no? No? Now? Okay, good. Okay, so the CFP mentioned something about serverless and clouds. So this talk is about logging with serverless and clouds. So who I am. So I'm a software engineer at Lyft. My name is Paul Fisher. I've been working on infrastructure for far too many years now. And sometimes it seems like I keep solving the same problems over and over again. So most recently, I built out the current logging pipeline at Lyft. So I'll cover some of the history of monitoring at Lyft as well as the current logging pipeline that we're using here today. So some backstory. A lot of my work has been at startups experiencing kind of crazy growth curves. It's just kind of what I tend to go to. So as part of that, sort of before you have a few thousand microservices, you usually start out with a single application a handful of engineers are working on. And so we'll call that a monolith. And of course, you need some way to monitor that monolith. And so usually you start with logs, because logs are built into all of your language libraries, like pretty much regardless of what the language is. So in this case, this is some Python code, but we get a request, we log the request body, we process the request, go back to response, we log the response, return a 200. And sort of like the main thing that's going on here, like, which is also kind of annoying, which doesn't really scale very well, is that you're logging the entirety of the request and the response, even though it's a 200. So eventually you have some logs, you run tail on them, maybe you grep for 500s, you eventually call out to PagerDuty, throw in some bash as you add more servers, but fundamentally at the end of the day you end up with just tail, which doesn't really scale that well. So assuming that your monolith and your service has a bunch of growth, maybe because people decide that ride sharing is a good thing and pink mustaches are good ideas, eventually your logging visibility sort of looks like this. So tail is a really bad tool for telling you what's broken on your site, even if it's one large application. So you have this log hammer, and it's built into your language, so why not keep using it, right? So there are a bunch of companies which will encourage you to keep up this practice, and they'll give you dashboards, and they'll generate metrics from all of this. And from those logs, they'll want you to ship them absolutely everything. Some of them will want you to downsample after you send all the logs to them. And so the fundamental problem here is that scaling strings and large blobs is really hard. And then additionally on top of that, so you have all these strings, you ship them off, now you have to run regular expressions on them. And you have to run the regular expressions over and over and over again, and that takes a lot of CPU time. So once you move to this, and you can make this work, but if people still really like your service, and your service keeps growing, you sort of end up with a different type of fire, which is this one, which we talked about earlier. So it is possible to scale logs to handle absolutely everything. Like, you can do that. But it's really, really expensive. And I guess unless you work in the enterprise, because apparently they have as much money as they need, it's not really a good use of funds. So in our case, we think it's better to direct the funds towards the core business instead of just feeding this fire. So roughly at this point, you decide we're spending too much on logs, and it's time to implement a stats pipeline. And that's roughly when I joined Lyft. So we added a stats T pipeline. Jan talked about that a bit earlier. And we started the effort to sort of move the engineering culture over from having logs to stats. So in general, stats and tracing should be your primary means of observing the state of your infrastructure. They're numbers and they scale. It's a lot easier to scale these. And so most importantly, which I guess a lot of people, well, something that we've had to work with the engineering org on, is that if your service is healthy and it's doing fine, you shouldn't need to log anything. Have as many metrics as you want about what's happening with your service for that 200, but at the end of the day, you shouldn't need to generate logs for that. And I talked about this a bit earlier, but please don't log every single request and response body that your service handles. It's pretty common that someone will spin up a new service, and they're testing it, they're debugging it, it's not in production yet, and so they want to log everything, and then they shove it to production without actually turning that off. So at this point, we're still growing as a service, and we need to reduce the cost of logging pipeline. And so this is a graph of sort of a generic logging pipeline. So you have all your services, they generate logs. You need to aggregate all of that so you don't overwhelm your database with hundreds of thousands of concurrent connections. And then once you've written your data, you have to be able to search it, generate dashboards, and you have to alarm on it. So some of our constraints, the vast majority of our infrastructure is in AWS. And then for the pipeline in particular, we'd prefer that it be vendor neutral. So again, we can choose different vendors for different pieces if we have to move them around and or insource them. And one other sort of thing to note about Lyft's infrastructure is that it's sort of set up, it handles stateless infrastructure really well and it's not really optimized for handling stateful problems. It's just sort of how we've built the service out over the years. And in particular, our infrastructure looks quite a bit different on a Friday evening versus, say, an early Sunday morning. So it scales up and down based on load, and ideally we want the logging pipeline to do the same. So this is our current logging pipeline. The red circles, yeah, that shows up okay. The red circles are local infrastructure, and blue is everything that's serverless or in the cloud, i.e. not managed by us directly. So I'll cover all the connection points in a bit, but it's sort of the high-level overview. And in our case, we try to make sure that when a service writes a log entry, that it's available for searching in Kibana within about a minute. Okay, so the first stage. To get logs off of our servers, we use Heka. So it tails all the log files, aggregates the data into JSON bundles, streams them together, and ships them off to AWS Kinesis Firehose. For that JSON blob, we include a timestamp, the service that we're reading logs from, and the file path. And so there's an example of this on the slide, but it's essentially one JSON object per line, and that's what that looks like. And one very common question I get is, why are we using Heka? Because it's been end of life by Mozilla, and somehow open source software stops working when it's been end of life. But it doesn't. So we used it for a prior project for proof of concept. It worked really well, and so we're like, why not reuse it for this project? And if one day we do have issues because it's been end of life, like we can replace it. But overall, this has been one of the most stable pieces of the whole pipeline. Like, it just works. And in the future, we're also considering other options other than just tailing log files, where we could inject data either with gRPC or protobuf, which Envoy uses for service-to-service communication. So we'd like reuse that infrastructure for the logging side, but we're not doing that yet. Okay, so once Heka has it, it gets shipped to the AWS Firehose. So every single instance that we run on AWS is connected to the Firehose. So all that data gets aggregated together and written in real time to S3. And the S3 storage is our permanent archive of all the data from our servers, in this case. So AWS gives you a few toggles that you can change on this that determines how often it flushes to S3. In our case, we never hit the per second modification lag option because we're always writing enough gigabytes where we flush based on that. So it's always less than 60 seconds for us in terms of flushing to S3. The Firehose also compresses data. It's really super cheap. And so far, we haven't had any issues with scaling it or having Amazon up the limits to keep up with our growth. In particular, the Firehose has this really neat property that they will retain all data for up to 24 hours if the downstream service is not available. In this case, that would be S3. So for the outage that happened earlier this year, multiple hours, our logging pipeline was down, but we still had metrics and tracing available. So all of our core systems and alerting, all of that was working fine, but our logging pipeline was temporarily down, but the pipe from Heka to the Firehose was working fine in that sense. Like, it was getting 200s as OKs, everything's in the Firehose, and it just gets buffered. So as soon as S3 was back up and running, then the Firehose flushed everything out. And sort of interesting story, we did contact AWS when S3 came back up, and they're like, hey, can we please flush this faster? They said no, just because like every single customer and like, yeah, essentially like S3 was going full out when it came back up in terms of like capacity. So yeah, it took a little while to flush. I seem to recall it was like on the order of like an hour or so. And then all that data ended up making its way through the rest of the pipeline. Okay, so some stats on the Firehose at Lyft. So we shove around 10 gigabytes per minute into it. And there's also this metric that AWS keeps called data freshness. It's sort of, I guess roughly you can think of it like P99 or P999, where this is like the oldest absolute record in the Firehose that is yet to deliver to S3. And that stays around 20 seconds or so, but most data ends up getting written to S3 before that. Okay, so the next piece is Lambda. And if you're not familiar with that, Amazon has a service where you can write a function in one of a handful of languages. Python's one of them, so we use that. And then they'll just schedule that function and run it as much as it needs to run. So some other constraints, execution time cannot exceed 5 minutes. So if you're doing some operation and it takes more than 5 minutes, they'll just hard kill that function call. It's also guaranteed that you'll never have concurrent invocations on the same machine, where a machine is probably implemented as containers on their side, but it has some nice properties for when you're writing your function that you don't have to worry about multi-threading or something else stepping on top of your function that's executing. So the pricing for Lambda is really, really, really cheap. And they bill in terms of increments of 100 milliseconds. at a particular memory footprint. So in terms of like when you're setting up your Lambda and in terms of how it's billed against you, CPU doesn't come into the equation. It's all based on memory. But the CPU scales with the memory footprint. So for example, if you go from 128 up to 256, then you get double the CPU, and it doubles the cost of that particular 100 millisecond increment. Okay, so we use Lambda for, the main function that we have in Lambda is our log ingest. It parses a single firehose bundle on S3 one at a time, and it stays CPU bound because it's really just doing a whole bunch of string manipulation and shoving data around the network. So one kind of particular item of note, which is not necessarily immediately intuitive, is that because we're CPU bound, we can actually increase our per 100 millisecond cost. So like, for example, if we like double that, that also doubles our CPU, which means that we have the amount of time that it takes to process that packet. So we've made the pipeline faster, and our end cost for running that function stays the same, even though everything's been sped up. So yeah, overall we fit into the smallest Lambda that's available, which is 128 megs. We don't run at that because we want more CPU. So again, so we can like get through the pipeline faster. But the way Lambda does billing, they calculate based on resident size of your application or your function and how much it uses. So it doesn't take into account the page cache. So we stream to disk a whole bunch as part of our operations, and that ends up being really fast and doesn't really use any memory. So we pull a file down from S3, we save it to a temp file, we kind of fan that out, I'll talk about that in a second, and we shove it back off to Elasticsearch. And here's like a random CloudWatch graph. So where we get like 10,000 notifications per hour roughly. But essentially, at whatever rate the firehose is writing bundles in S3, that's how often our Lambda function gets called. Okay, so kind of going more in depth into the Python function. So this is the basic flow of our Lambda function. So an S3 write occurs, AWS calls our function. So it goes into the Lambda handler function there. So we pull down the S3 bundle, we decompress it, we parse it into JSON, then we break it into multiple temp files per Elasticsearch document type. So this all like fans out onto essentially the temp file system. And then we use requests to stream it back into Elasticsearch using the bulk API. Okay, so this is sort of the core of our logging pipeline. So in addition to talking to Elasticsearch, our Lambda function also talks to SQS, where we store state for failure cases, as well as Dynamo to keep track of per service ingest rates. So we can do rate limiting. Okay, so here's a list of a whole bunch of properties that our function has. So we're almost entirely stateless for Lambda, which works out well, because Lambda doesn't deal with state very well. So our function processes at most 2 bundles any one time. The goal is like we have to be done within 5 minutes. Ideally, we want to be done way before 5 minutes is up. And in the normal case, we only process 1 bundle. So when Elasticsearch is having issues, we found it's best to not keep hammering it. And it's best to sort of like, as soon as you realize there's some sort of disturbance in the force, to back off and give Elasticsearch a time to either heal itself, move shards around, whatever it's doing, and get into a better state. So if that happens, where we're getting some amount of back pressure, depending on how bad things are, we'll either might retry once with the hope that we get another node that's up and is working well. But if it's not, then we write the name of the bundle, so it's only a very small amount of data, to SQS. And so that's basically a work queue there that we have to backfill later on. So one really, for this whole system, sort of like one of the properties that I think is kind of the coolest is we get sampling for free. So we have Heka and the fire hose are all sort of like combining data together sort of randomly, concurrently in real time. So the end result of these bundles that get written to S3, it's sort of a random mishmash of everything that's going on in the system. At any given time, there's no like particular ordering other than the time. So if we get a huge spike in load all at once, and Elasticsearch can't handle the full write load, then whatever data ends up making it into Elasticsearch for that given time window, that's the data that Elasticsearch has. And that's usually enough data that we can triage and debug what's going on. And so anything that doesn't get written while there's a problem, that all gets pushed back into SQS so we can automatically backfill later. But it doesn't mean that in sort of situations where there's like huge spikes or something happens where ES just can't keep up, then we have enough data where we can triage and figure out what the problem is. There are other logging systems that try to be, I guess, perfectly consistent, where if they get overloaded with the amount of logs that are going into them, they'll just start falling back in time. So, as an example, we've had situations in the past with like older systems where there's this huge spike and our logs are delayed by like 15 minutes or half an hour or something like that, which isn't really useful because then you're trying to like debug what's going on and all your data it's not now data, which is what's important for triaging. So this is like a really useful feature. So again, I mentioned that we write to SQS when there's an issue. And so what we do is the next time, since we try to be stateless, the next time that we run a Lambda, if its connection with Elasticsearch is perfect, so there's like no issues, no blips, no retries, no nothing, then we'll take a work item from SQS and then process it. So at most, we run it roughly 2x, I guess you could say. So you always have the current bundle that you're trying to put into Elasticsearch. And then if that goes well, then you also can pull off from SQS and process one more. So it's like one or two, and then you're done. And more recently, we added rate limiting. And this is to handle the case of where, usually the case is a developer adds a log entry inside a really tight loop, and they ship it to production. And so in this case, they just shoot themselves in their foot as opposed to the rest of the engineering org and all the other services. So this is all based on Elasticsearch 5. We have time-based indices. So we have a cron lambda, which runs once a minute. It's pretty simple. And it carries out all the recommended maintenance operations. Elastico has a blog entry on this, and our cron essentially implements it. That's what's in the paper. So roughly every hour or so, we roll over our active index. Then we move all the shards to a single node. We shrink it. Then we force merge, maybe, it depends. And then this also cleans up when we need to free up some disk space. So Elasticsearch is really great, but it only speaks JSON. So prior to moving to Elasticsearch, we had a handful of different on-disk logging formats. So in our Lambda function, it has this property where if it gets a log that it doesn't know about, it'll try to figure out a timestamp from those logs. If it can't find a timestamp, then it'll take the timestamp from the Heka bundle, because that's a JSON blob that has a timestamp on it. And then what we do is we increment the number of milliseconds for every line within that Heka bundle. So at least if you're looking at logs in Kibana, they'll be correctly ordered. So we've been moving everything over to a structured logging format. This is an example of what it looks like in Python. So we just extended the base API to take a key value argument, which is a dictionary. And you can put anything in there that's serializable in a JSON. So as an example, it's fine to have a dictionary within a dictionary. And then on the bottom is what it looks like on the system itself. So if you are still using tail, then that will work fine if you're just looking at logs. So there's nothing too special here. We use Kibana. It works okay. It's hosted by Amazon. So yeah. So one sort of interesting caveat about Elasticsearch, at least the hosted version that Amazon runs, it runs on the public internet. And so in order to communicate with it, because you want to lock it down because it's on public IPs, you either have to cryptographically sign your HTTP requests, or you have to whitelist by IP. And we have cluster authentication proxies in our VPC. They just run Nginx as a reverse proxy. And there's a Google authentication in front of that, so engineers have to authenticate before they can get to Kibana. And one other nice benefit of this is since Kibana doesn't know what a user is, because they have to Google authenticate, then we at least can associate queries and entries requests with who the user is. And then Amazon has a full white paper on how to set this up in order to talk to Elasticsearch. For logging, we keep metrics on all the different log levels. So if the logging error rate spikes for a particular service, we can page via our standard metric setup. So we don't actually need the logging system to page someone if logs go crazy, because the metrics pipeline handles that. There are a handful of cases where we do need to alert based on the content of logs. There are a whole bunch of cases where monitoring just standard system OS logs. And so the security team gets paged for things like that. So we use LastAlert. It's written by Yelp. It's open source. It works okay. We're not terribly concerned about this system being highly available because so much of our stack we depend on the metrics pipeline. And so this mostly works. It's fine. But if it does blip, all of its state gets stored in Elasticsearch, and Elasticsearch should be highly available. So it just comes back up and picks back up where it left off if we have to stop it or start it. Okay, so on to scaling Elasticsearch. For AWS, if you're used to AWS or you've used it, for any web form element, you always want to scroll all the way down and all the way to the right. And if you get into a state where you can't go down any further and you can't go right any further, then you should contact your AWS rep and ask them to add more options to that particular web form. And so as far as Elasticsearch itself goes, standard scaling rules apply. Usually you want to start with a large cluster and sort of scale down to find out what works. In our case, we found better performance for running smaller clusters with larger capacity instance types rather than big clusters with smaller instance types. One thing to note is that when Elasticsearch moved to version 2, they started to implement ACID-like database properties. We don't care about that at all for logging. So in our case, we really, really, really want to set async mode because performance is really bad if it's not async. It's close to useless in our situation. Because we use it mostly for triage and it's sort of best effort, if we have a few seconds of data loss because we lose a node and it comes back or whatever, that's okay. In the worst case, we can backfill from the S3 bundles. Some other notes, you probably want to use local storage as opposed to EBS. That kind of depends. And then if you can, having multiple clusters, separating them out by document type might be more useful. In our case, we have one really large cluster, which we sort of use for triage that all systems go into. And then another example is we have a separate security cluster, which has a much longer retention period and has less load on it. So our original cluster that we built for this pipeline, 10 nodes, a whole bunch of RAM, and a whole bunch of page cache that we use the RAM for. So this would do about 10,000 JSON documents per second. We have a whole bunch of fields because the monolithic application that I talked about earlier, it natively logs in JSON and always has. So we burned through a lot of fields as part of that. So all this was working great. We survived New Year's this past year with this pipeline, worked fine. Then growth has still kind of been kind of crazy. So more recently, we sort of got back to this state. It's not quite as bad as before, but we're having to rely more on SQS back pressure, and we're having to scale the cluster more. So it's kind of the state that they're in right now is in terms of scaling Elasticsearch portion of this up. So the available managed Elasticsearch services are mostly designed for homogeneous clusters. A lot of them are designed more for the database use cases where you do want ACID-like properties. And so logging tends to be more of a specialized use case, even though it's not for this conference or for us. And so depending on your vendor, you might have issues with support response time, or you need access to Elasticsearch logs, or you need to run perf, or you need to add a bug fix, or you need a new version to upgrade. So there's a whole bunch of use cases of why you might want to insource Elasticsearch or use or use a different vendor. It's just one of the pieces that you might want to move around. And so that's what we're currently exploring, that option of insourcing the Elasticsearch component. So as an example, this kind of comes from Elastic's blog on like the sort of like best practices in setting up a logging cluster, and that you want hot nodes for your ingest, and then you want a different type of node that just handles reads after you do, say, your hourly rollover or so, and then you might want to have cold nodes that do nothing but leucine segment merges. Okay, current status from metrics. Jan talked about this earlier, we're doing about 20 million metrics per second with either 60-second or 1-second rollup. On the logging side, we handle about 15,000 JSON documents a second. And overall, I'd say we've done a reasonably decent job of moving the organization from logs over to metrics. And I guess it's roughly around like 1,400 metrics for every log event that we write. So in conclusion, use metrics, not logs. And if you must use logs, serverless works pretty well. Thanks.
Okay, it's break time. It's a longer break too. It's 20 minutes, which means that you have enough time to look at Jason sign some of his books, and maybe you can get one. But break's back there. See you in 20 minutes. Did anybody see Jason writing on the thing that Jason already wrote? Yeah? Oh, you did? You have one? You have one? Awesome. Cool. I didn't know it was real. So a quick announcement before we get to our final two talks. You may be interested in more details regarding the hike. Cool. The hike will be leaving from the street in front of the venue at 5:30. We're going to walk to the park, which is about a half hour. And so if you want to meet us at the park, you could plan to get there about a half hour after 5:30 or 6 o'clock p.m. And then once we get to the park, we'll decide what we want to do, but we'll probably at least walk around inside the park for another 30 minutes before a group heads back here. And then you should have plenty of time to like get snacks and drinks and stuff. Sound good? You don't have a choice. Okay. So we have two more talks, and I won't make you do any participation stuff as long as you look like you're focused, engaged, and excited. I didn't ask you to do anything. So that was all you just choosing to do it. Stop now. All right, please, warm round of applause for Yuri.
Is the mic working? Yes, thank you. Thanks. All right. Thanks everyone for sticking around for the last time segment of this conference. This is my first time. I think this has been an amazing conference, lots of interesting talks. And since this is the last segment, I promise there will be no math in this talk and no cat pictures. Even though I have a cat, but well, I can't, like there's so many already. So I have to skip that. A few words about me. I'm an engineer at observability team in Uber NYC. This is a picture of me. This is actually an interesting picture because this is all of New York office about a year ago, including engineers and ops. And we're facing the river, so there are no buildings in front of us. So you can guess how that picture was taken. So I'm working on the distributed tracing team specifically. We've built open tracing and open source tracing system called Jaeger. You can check it out on GitHub, and I'll show it quickly. I also was one of the co-founders of the open tracing project / standard that has been mentioned a few times. And before Uber, I worked for way many years in the banking industry, more than any engineer should really. And like the idea of monitoring there was a trader calling you and yelling that he can't book the trades anymore. And also I have an alternative talk for this, alternative title for this talk, like would you like some tracing with your monitoring? And really what I'm going to talk about is what it actually takes to roll out a tracing at a large organization, or even not necessarily a large organization. Before we do that, just like a quick recap for people who may not be like deeply familiar with tracing is why we're even doing distributed tracing, right? So first and foremost, distributed tracing is it's a monitoring tool for distributed transaction monitoring. And what we mean by that is it means like we observe how a transaction, a given request travels through the whole architecture, through all the microservices in your system, and we can measure things, we can collect logs and tags about that information, and most importantly, we collect like causality of the request. So it's very rich semantic data that none of the other like monitoring system can actually collect. So logging can, but logging is later on hard to correlate. So with tracing, you get very strong correlations between what happens after what. Also, tracing, as we've seen from earlier talks, like from Ben's talk especially, is very strong tool to use when you want to do some performance or latency optimization, as well as root cause analysis. And one thing that hasn't been mentioned much in this conference, at least this time, is that tracing is also very strong source of data for service dependency analysis, meaning that if you have a large architecture, like at Uber, we have actually several thousand services. So no one engineer at Uber knows how this whole system works, right? It's just impossible to keep it in your head. And then tracing can actually take a look at all the data that's flowing out through that architecture and say, well, this is how it works. You can actually observe it empirically, even though you may think that certain things are communicating in a certain way. Well, tracing actually tells you how they're communicating, right? And finally, tracing is provides this feature called baggage propagation, specifically the open tracing interface gives you that. And it's not specifically a tracing feature, it's actually a foundation for tracing. I'll talk about it later a bit. And also, like a quick plug for Jaeger. So we've developed it at Uber, but we've open sourced it recently. It's a tracing system. It's similar to Zipkin and Dapper. But it's built with open tracing standard inside. So like all instrumentation libraries support open tracing, and the internal data model is also open tracing compatible, so we can collect all the rich data provided by the API. It's an active development. We have 5 people on my team, and there is also a team in Red Hat who is actively contributing to Jaeger currently, plus I'm hoping some other people will. So if you want to participate in the development, PRs are welcome, and it's a very active project. And if you already have Zipkin installation in your system, that actually can work with Zipkin because it can interoperate on both wire and on the span collection layers. So now that I've talked about, let me give you like a very quick demo of what Jaeger is, and this is really not just to pitch Jaeger, but more to illustrate these features of the tracing that I mentioned before. So we have, if you go to Jaeger GitHub page, there's a demo application that we call Hot Rod, which is like a rides-on-demand service. So what you can do here is that you have some customers, you can click on one, and there's a kind of request goes to the backend, and you get a car in a few minutes. Very similar to Donut Salon, right, that we've seen yesterday. So one of the things that I mentioned is the service dependency discovery that tracing can do, right? So here's the, it doesn't show well. Let me see. So like this. So this is a diagram that was collected by the tracing system completely automatically, right? You don't have to tell it what services exist in the system, how often they communicate, what kind of requests went through. It's all automatic, and this is actually the most simplistic way that you can get this information from tracing. In fact, the tracing data is so rich that you can expand this into a lot larger graph, even with this number of services, but you can do it at the endpoint level. You can analyze different workflows. Let's say the front-end service here really has only one endpoint in this demo, but if you had different endpoints, then you can visualize completely different graphs with all the statistics, like how many requests were going through each edge of this graph. So this is very powerful data, which really isn't available in any other monitoring tool. That's why we're doing tracing, really. And another thing is, so if I search for traces for this service front end, so this is one of the traces that I would get from executing this request. So some of the other features that you already seen that Ben mentions, like if you want to analyze where my latency is coming from, so just like one glance at this trace, we apparently see a lot of like things that are wrong here. Like this is a MySQL request. Can you see that? It's a bit small, maybe if I can. So MySQL request took 300 milliseconds. That's not normal, right? Well, this is a demo, but nonetheless, this is very, like, we're just looking at the trace and we see what's going on. Another thing here is that a request to driver service took another almost like 300 milliseconds, but we have a staircase pattern. So that's obviously like something bad going on in the service. Like it shouldn't be colon ready sequentially. It's probably can parallelize this thing. And finally, in the last stage, here there's some parallelism going on, but it's 3 at a time. So some thread pool probably limited by the number of executors that you can. So again, very quick look at these things can tell you a lot about what the system is doing, right? And also you can understand like how the services are communicating to each other. And if you want, you can actually drill down and say, okay, well, this is what the SQL request that was executing, right? If you want logs, well, let's drill down to this one. Look at this. It has like very detailed logs about the whole execution. And those logs are not just like you collected a whole bunch of entries, events from all of your instances that potentially every service runs in its own host, right? In Elk or in Elasticsearch or any log aggregation system, if you jump them together, you're never going to get this kind of picture because here, these are the logs that happens only by this service within that time frame, right? If you want some other service like MySQL, then okay, well, it will have its own logs. And so you get logs in the context of the things. Remember the context, the pizza pictures? That's what tracing gives you. It's not just like, oh, this is my time sequence of logs that happened. And obviously, if these things are concurrent, then looking at your log like standard output is going to be completely useless because you're going to get like hundreds of requests simultaneously. So it's I will stop here because, like I said, it's a very quick demo. I don't want to spend too much time on it. So let me switch back. Separate display and this. Okay. So now we've seen that. Who thinks that tracing is awesome, right? Oh, pretty much everyone. Cool. Now, so what do you think, how widespread tracing actually is? There was a poll recently on Twitter that Open Tracing Twitter account ran, and the results of this poll are kind of interesting. So like 42% said yes, that they have fully functional tracing solution in their organization, and another one I find interesting is the 14% was distributed tracing, right? So what do you think about these results? Well, to be fair, that poll was systematically challenged, right? Because it ran on an open tracing channel. So, like, of course, people who are following open tracing, they will know that, like, what tracing is. But the 14% is still kind of interesting, right? So, anyway, so if tracing is so awesome, then why doesn't everyone doing that? So like, actually, let's have a show of hands like here. So we actually have like 5 times more people than that poll sample, right? So how many people have tracing in their systems? If I can count, maybe 10–15%. Well, that's what I would expect, right? So definitely not widespread, not 42. So why? And the simple answer, to me at least, is that because tracing instrumentation is too hard. It's expensive, and as Aditya said on Monday, it's boring. We can argue about the boring part, but it's definitely, actually all these 3 adjectives refer to the same thing, to the fact that you need to spend time to instrument your systems, your frameworks, in order to get high quality tracing data. And well, you could say, well, you could have to do the same thing for logging and metrics, right? But not quite. So logging and metrics are actually the old school monitoring tools. People understand them well, and they actually don't require as much work to instrument as tracing does, and I'll show you why in a second. Whereas tracing it's both a new paradigm for many people. A lot of developers don't even know what tracing is, distributed tracing. And it's actually harder to instrument your system to get the tracing correctly. And so why is that? And the reason is because tracing fundamentally relies on a thing called distributed context propagation. And what we mean by that is that, let's say you have a request which goes through your architecture like this. This is like the call graph of executing one single request from the edge service, right? So context propagation means that we associate a certain metadata with that request, with that distributed transaction, and we pass that metadata around through all the RPC calls that are happening. This kind of sounds very simple concept, but is that simple? So if we look inside one node and see, like, try to decide what actually takes, what it takes to do that. And so let's say we have a microservice. It's both a server, it serves some inbound requests, and it's also a client for some downstream calls, right? And we have this instrumentation in purple, I guess, not purple. I can't tell this. So instrumentation takes care of extracting your context, your metadata from the inbound request, maybe from HTTP headers like a trace ID, and encoding it into some object in memory. And then by the time you make a downstream call on the client side, instrumentation again takes over and says, okay, that context object, I'm going to encode it again into the outgoing requests, HTTP headers maybe again, right? So again, it still sounds simple, like how hard it is, right? Just put some filters on the server and client things. But the difficult part here is the dotted line between the context boxes, because in order especially for the instrumentation on the right to be able to encode the context, it needs to have access to that context. And well, that's where the difficulty is, because how do you pass it through? So this is a problem of specifically in-process context propagation, ironically. Like, distributed tracing is all about inter-process communications, but the biggest challenge in instrumentation is in-process. And it's not all bad. Like, if we take some languages which support thread locals, then you can do that actually there. You can just stick that context object into thread local and it's available everywhere. So it's not so bad. So it's kind of a happy story. But, oh, my picture didn't show, fine. Happy story, but you have still an issue with thread pools and futures and asynchronous communications. They will actually break that, even that simple solution, because, well, thread locals are only good if you stay on one thread, and that's not what modern systems do, right? However, we have another set of programming languages, like Golang and Node specifically, where thread local storage doesn't exist. In Node, there is like a continuation local storage, but not a lot of people using it. It's like considered expensive for performance reasons. Then Go has nothing at all. Like you can't even identify a Go routine in Go. It's a decision by the language specifically. And so what you have to do is you have to pass the context object explicitly throughout your application. So imagine like actually if you go to Go language block, they have a standard library and standard object called context. And if you read the block about that, it says you should really pass it as a first argument to every function in your application. Let's not debate how good or bad that decision by the language is, but it's pretty hard in terms of like, if you've written your application without doing that, then changing it isn't cheap, right? You have to do some work. And therefore, it's not such a funny story here. So in-process propagation is definitely one of the biggest challenges. But another one is also, well, we said that instrumentation for the frameworks is kind of easy, put the filters. But I come from Uber. Uber is a snowflake. So we have 4 programming languages that I showed before. But we also have, like every team essentially wants to, whatever they want to use as a framework, they use it. Right? So every language has dozens of different frameworks doing similar things, like whether it's HTTP or database access. And me, as a tracing person, like on a tracing team, I kind of have to go and instrument every single one of those so that regular developers don't have to. Otherwise, I just can't like scale this thing, right? So I need to instrument all my infrastructure libraries. So that's very expensive. And that's actually where open tracing comes in, because open tracing is an open source standard for instrumentation. It gives you APIs across different languages, like 6 or 7 at this point. And the idea really there is that, so we've heard probably for some of the vendors that they do like monkey patching, the implicit instrumentation with agents, which is great, like if you don't want to touch the code, but it just doesn't always work. And it's actually very expensive to the vendors themselves, because like if I write a newer RPC tomorrow and it becomes popular, then every vendor has to go and write some sort of monkey patching for my RPC with my API. And then in my version 2, I break them because I changed my API, right? So whereas when I'm writing my RPC framework, I say, okay, well, I want to support tracing because I'm like a 2017 developer. I know that tracing is important in distributed architecture. So I can instrument my framework myself. It's not going to take me a lot of time. I just need an API. And until open tracing, there wasn't such API to use. Now there is. So the hope is that open tracing will kind of help people instrument their frameworks. Or if not the owners of the frameworks, at least you can write a plugin for the framework. You have to do it once and then everybody can use it, rather than everybody re-implementing that stuff. But open tracing still doesn't help with the in-process propagation. It still must be done manually, and specifically at Uber, we have between 2,000 and 3,000 microservices. And the reason I'm giving this kind of vague number is not because it's a secret, I just don't know anymore. Like we used to track it, whatever. At some point we had more services than engineers, so we had to hire our way out of it. And on top of that, I have 5 people on the tracing team. So obviously we cannot go and change, like I said, if it's a Go service, so a quarter of those services will be in Go. I cannot go and change all the Go services to pass the context around, right? So it just doesn't scale. So developers must instrument their own code. What do developers tell me when we ask them to do that? Like, how do we mobilize the organization to actually go and do that instrumentation? That's actually a very hard problem. I call it a traveling salesman problem, 2017 edition, because I am a salesman, I'm building a service, a tool for them to use, so they are my customers, I have to convince them they have to use that, or like they want to use them, that's why I sell them. While as a traveling, well, it's really an optimization problem. How do I optimize my resources on my team to give the biggest impact by doing whatever work we're doing for the whole org and make it easy for everyone, all right? And after doing this for 1.5 years, I think that problem is also NP hard. But kind of the main conclusion is like if you want to roll out tracing in a large organization, you have to make them want to use tracing, right? And it sounds like from that demo and from the reaction that it's like, well, why wouldn't everyone? But we here are the monitoring crowd, and that not all developers have that mentality, right? A lot of developers want to I just want to ship my features and bite me, like with your instrumentation and monitoring. I don't want to do that. So to that, we have another approach, which is sticks and carrots, right? So, and I'll talk about that in a second. But so, as a recap, so these are the features that I mentioned. Sticks and carrots, we all know what it is. Like we need to give them something, or we need to like make it expensive for them not to do certain things, right? So, what can we give them to actually make them interested in instrumenting these things? And ironically, tracing initially started as this kind of, oh, this is an awesome tool for investigating latency performance problems. This is not what being the most frequently asked use case at Uber at all. The use case was service dependency analysis. People just saying, okay, we just built this 2000 microservice architecture. Could you please explain to us what the hell we just built and how it works? No one knows. So SREs, like we have, there's a talk from Lyft about like the diagram where there were no services names, but there's like, it was talking about trip flow, right? The core services that critical for trip service, for trip flow. We have the same thing. And SREs in our organization actually introduced the notion of service tiers. So we say like every service which is critical for the fundamental business of Uber to taking trips, right, is like a tier 1 service, and it has additional restrictions on top of it. Like you cannot roll it out globally, you have to do stage rollouts and all kinds of like gates and checks and balances to make sure that there is stability in the system when these services change. Because, well, I don't know if you know that number, but 80% I think of all the outages are due to changes in the system rather than like when something happen, you know, nodes go down. So these are basically the main thing that people are looking for tracing. And with the service tiers, we actually had a project where we picked a bunch of high-level entry points into our system, which were responsible for, we knew they were responsible for the core trip flows. And we said, okay, well, what if we just trace those requests through the architecture and see every service that comes up in those traces is, if not critical, then at least it's somehow related to the core trip flows, right? It could be cached, so it's like there may be soft dependencies, and there are ways of dealing with that, like automatically figuring that out too. But that was a very like a strong and useful project, and we've like now we have like a 5-tier hierarchy at Uber, which is in part based on tracing data that we collect. And the last one is the workflow analysis. Here, that's actually what I refer to saying that the dependency diagram that I showed is the most primitive form of dependency diagram you can build with tracing data, right? Workflow analysis is really, well, this core trip flow was actually an example of flow analysis because we've looked at what it takes, what kind of graph we get by executing one single flow. And we can study that. We can like calculate how much traffic goes through each flow. So if you're a service owner and you see 50% of the traffic comes from here and from here, there's little you can do to actually attribute that traffic to any particular business use case because, well, maybe you are a storage service and all the context you get in the request is they tell you, give me the customer ID, right? So like that's it. You can't attribute it to any kind of business functionality. But with tracing, you can. You can just trace it back and say, okay, well, this was actually payment, important for the business, or this was, I don't know, some whatever, some feature which isn't that important, right? But it takes 50% of your traffic, so you can badge it and maybe tell them to put a cache or something rather than hitting you all the time. And the second interesting, like most useful use case for tracing turns out in Uber was baggage propagation or distributed context. So baggage is that metadata that we propagate, and that metadata doesn't have to do anything with tracing. It's just the fact that you propagate in the metadata, which is a key value store, essentially arbitrary. But it's very powerful technique, and in fact, like it doesn't have to even exist with tracing. You can build that without tracing. And a lot of companies, like if you look at what their services are doing, they actually often build that manually with like, oh, I'm going to propagate this particular HTTP header manually. Why is it bad? Because, well, when next day when you want a new header propagated, then your service somewhere in the middle of the stack doesn't know about it and it doesn't propagate it. Whereas baggage is fundamentally designed such way that services don't need to know. They just propagate blindly unless someone actually reads that data. And so we're using that for two primary purposes. One is the tenancy. So the request comes in, maybe we check, well, it's a test account, or maybe it's like a, what's it called? Not chaos monkey, but essentially a performance test, right? We like flood the system with a lot of requests, but we mark them as test requests with a test account. So edge service can check that, and it sets that tenancy. And then as the requests go down all the way to the storage then at the very last point says, oh, you know what, I'm not going to point you to the production database, I'm going to fork you to a test database so that you don't mess anymore. But everything else in the stack doesn't even look at it because they don't care, they want to exercise normal business functionality. And the similar thing with authentication tokens, like you stick it somewhere at the top of the graph, it's available at every node in the rest of the graph. So why am I actually talking about this? It's not exactly tracing. It's kind of back to sticks and carrots, right? So these two teams that do the tenancy and authentication, they are not tracing team. They're teams that build functionality on top of tracing. And that's kind of the very powerful tool in the organization. If you get people to build features on top of what you're providing, then you essentially increase the number of carrots because there are some other things that developers may want to use, and in order to use them, they have to integrate with your tracing system. And sometimes they can become sticks because well, tracing and context propagation only works when it works everywhere. Like if there's a break in the middle of your graph, then people will start yelling at you, why haven't you propagated the context? We can't see what's going on in the storage, right? So as a summary, each organization is different. You have to find your ways. You have to solve the traveling salesman problem if you want to roll it out. Of course, if you're a Java shop, you're done. I mean, if you just like drop an agent, or it's very simple to do in a language which support kind of thread local storage. Like in Python, our story for Python at Uber was extremely simple. It's like a config line change, and boom, your service is instrumented for tracing fully, like propagation and all. But with other languages, it's harder. And the final thing, I have, I think, 4 minutes. I want to say, like, if you rolling out this kind of feature across the organization, it's a monitoring feature, you have to measure it, right? And so how do we measure adoption? We originally started with a very simple approach, saying like, so tracing means that not only you propagating the context, but you're also collecting the tracing data, like the tracing spans, and sending them out of the process. So when we see a service doing that, we can say, check, service is instrumented. So that's what we had as the first approach. And there's some daily aggregations of which compares the list of services from some registry with what the data we're getting, and says, okay, these services are not sending us any data, they are not instrumented, let's open up a ticket for them. Especially if they are like a higher tier service, then it may be even a requirement from SREs to implement tracing. And definitely show them a dashboard where people can go and check what's going on. So we started with that. We moved away from that because that kind of measuring, because the problem with that is like it's a pass-fail and it's very easy to pass. So imagine that back to that picture of the server and the client, the application, right? So if you instrument your server endpoint and you send spans and traces out of it, technically, by this criteria, you already integrated with tracing. But you may not be propagating context in process, which is the hard part. You may not be sending the traces, like continuing the traces to all the downstream calls. So really, you're not acting as a good citizen in a tracing, but you still got a pass in this criteria. So we switched to another thing, which we actually run another kind of aggregation jobs, and we calculate tracing scores according to a number of criteria. So for example, we see that like a service got called from some service X, and the service that got called is actually instrumented, so it emitted some data tracing, and we say, oh yeah, we saw the call from A or from X. But X never sent us anything, but we know that there's a break, right? And so X may have been actually instrumented as a server itself, but it doesn't work as a client, as a tracing client correctly, right? So we can detect that in the traces by examining them. You can also join with some other data, like we have our routing layer similar to Envoy. And we also used to use like HA proxy. We're migrating away from it. So we can get like some logs from there and basically say, okay, we see communication between these two services, but this particular communication is not showing up anywhere in the traces. So it's like a red mark against that service. And so we collect these metrics and we book tickets for people, for owners of those systems. And we also provide them like detailed reports like this one here. This is some service I just pulled randomly. You see all these criteria. Doesn't really matter what they are. You can actually define depending on your business case, because some of them matter to some people and not all. But we count how many traces we've seen, how many of them pass this particular criteria, and if not, we open a ticket and say, please fix that. And like sometimes the fix is as simple as just let's upgrade the tracing client. But in other cases, it's the instrumentation that needs to be fixed. So that's all I have. This is the summary. So the URL for Jaeger, if you want to try it out, this hot rod demo is all available. You can run it with like a Docker command, very easy. On the same page, if you read the README on that repository, there are links to two blogs. One is how we evolved distributed tracing at Uber. It's an Uber engineering blog article. And another one is if you actually want to do like the hot rod demo, try it out. There's like a very detailed walkthrough how you can try it. It's like what things you can see. And it really just demonstrates all the features of open tracing that you can experience with open tracing and with Jaeger as a kind of an implementation of open tracing. And open tracing itself, like open tracing website is open tracing.io. So that's all I have. Thank you very much. I think out of time, right?
And our final speaker for you, the few, the tired, the hardcore, thank you for staying. Our final speaker is Gianluca. Please, a warm round of applause.
Hello again. This time, I'm going to talk to you. I'm going to share a few stories about monitoring containers with a little bit of a tilt towards Kubernetes. So my name is Gianluca. I work at SysDig, and the problem that we have been observing for a long time now is this: is that for the vast majority of small, medium companies, monitoring should be something like this. You extract a bunch of data that enables you visibility into different layers of your infrastructure and architecture. So you move from the lower level provisioning layer towards language runtime, towards custom application instrumentation with StatsD or things like that. Then you pipe all these into essentially some sort of data engine that does all sort of, noise removal, aggregations, alerting and things like that. And then you, as a user, you should just have some sort of very nicely formatted dashboards that are really straight to the point and point you in a very easy to consume way if everything is all right. And many times you don't even want to see a dashboard, you just care about having just unicorn and rainbow alerts, let's call it like that. But what happens really is that we have observed that when you go with containers, the unicorn dashboards don't come out that much. And so I want to spend a few minutes telling you why we think is that. So pretty much I'm going to share a few best practices that we learned by working at this point with hundreds of small, medium businesses who are interested in doing monitoring in an easy way, but at the same time we're interested into essentially developing their workloads on containerized environment for all the benefits that they provide. And so for this talk, I'm going to use occasionally some of the SysDig tools, but this has to be taken in a completely vendor-neutral way. As long as as long as a particular monitoring or troubleshooting tools respects the best practices that I'm going to share with you, is totally fine. I'm just using those because that's what I'm most familiar with. So again, this is a standard that shows my very poor drawing skills. Just a standard infrastructure. We could call it a monolithic application or something like that. And we can see how the topology is pretty simple. And what happens with containers is that this workload is going to be scheduled in multiple copies among multiple nodes by whatever cluster orchestrator of the day you are going to be using. And all these workloads are going to be communicating with each other using all sorts of layers of virtual networking. If you've used containers, you know perfectly what I mean. So this clearly causes a big problem when it comes to monitoring visibility. So you have to be extremely dynamic, and you have to adopt new best practices in order to get the most value out of for the visibility of the environment. So how does all this impact monitoring? Again, by working with a lot of customers, we have identified that when you move into containers, when it comes to monitoring, there are 4 things that are harder to do now. The first one is, of course, getting the data, as we'll see in a second, because containers are isolated. So also the data in there is a little bit more isolated. The second one is because since all these workloads are highly dynamic and they move around, you need to make sense of the data, and making sense of the data comes with a few best practices in itself. Then the other element, which I already covered a little bit in my previous short talk, is essentially the troubleshooting part. So I have this idea essentially that as long as you have visibility enables you to do proper monitoring and proper troubleshooting. So monitoring and troubleshooting really, really go together, because monitoring, it's what ideally prevents issues from happening again, but troubleshooting is what enables you to find the root causes of the issues in the first place, right? And then the third one is the people. So we have observed that by moving to containerized environments and by moving to user-friendly cluster orchestrators such as Kubernetes, the developers who write the applications are much more prone to get involved with all the life cycles of the application. So we have really seen, traditional developers writing their own Kubernetes manifest to orchestrate the application in production, and then wanting to monitoring them. So the move to microservices and to containerized environments somehow has also an effect on the semantics of the team relationship from what we have observed. So getting the data, again, seeing inside containers is essentially a big pain in the ass. I'm sure if you've used containers, you know what I mean, from all points of view, from the troubleshooting point of view, from the monitoring point of view, because containers are isolated because of namespaces, and they run a very minimal runtime where you don't have all the tool belt of things that you might want to have when you have essentially a visibility issues. So, but at the same time, these are the exact same reasons why people are using containers, right? Because they allow us a much more dynamic workflow. So to extract metrics and essentially get the best visibility out of your containers, we have observed 2 strategies in the field. Again, we have these statistics of several hundred customers, so that's pretty significant. And we have observed that the first strategy is the one of leveraging the cluster orchestrator to somehow give you a hand when it comes to extracting metrics. So in the case of Kubernetes explores this concept of pods. So pods are groups of containers that the cluster orchestrators guarantees that they will always be scheduled on the same host. And not only that, but these containers, they will share some resources. In particular, they will share, in the case of Kubernetes, the network namespace. So localhost for container 1 is the same as localhost for the monitoring container. And they will also be able to share volumes. So something that you can do is you can deploy essentially a sidekick container along with the containers containing your application, and the monitoring container will be essentially, will contain all the logic to pull, for example, extracting the metric from your MySQL database or things like that, and making them available either with a push or with a pull model through your monitoring framework and to your big data engine that we saw in the first slide. This is a model that works perfectly well. It's widely adopted, for example, in Prometheus, which is a very popular monitoring monitoring tool for containers. And the only disadvantage is that, of course, you have to do a little bit of work every time you ship a new application or something like that. The other approach that we experimented at SysDig is, as I talked before, is to taking a look at a different angle. So the nice thing about running application on a modern operating system is that regardless where your applications are scheduled, whether if they are outside a container or inside a container, they will, at some point, every time they have to do meaningful work, they will have to talk to the kernel, right, via the system call API. So what happens if instead of going and poking inside each container, you just instrument the system call layer and you capture then everything that's going on in all container, and then you essentially direct this flow towards your monitoring agent that lives on the system. So by doing this, you are able to see inside the containers from outside the containers. And it's, I mean, actually it's pretty easy. So say that in container 2, you see that a new network connection has been accepted by Apache. And then from the cluster orchestrator, you get the metadata that this Apache was living in this specific context, in this specific containers. You correlate the two things and you have a container-aware monitoring tool without having to do anything inside your container. And again, we use a custom kernel module, but there are many approaches. So for example, we have seen a lot of activity lately using the eBPF framework in the Linux kernel that allows you to get very deep information from within the kernel in a completely safe way without having to, manipulate any potentially unsafe thing. And so this is how you get the data. Once you've gotten the data, you need to make sense out of the data. And as I was saying, this is something very important. And we have worked with a lot of customers and we have observed these 4 bullet items to be very important. The first one is that especially if you are, well, if you're a big company, yes, you can afford it. But if you're a small company, you should really not be involved in the craft of instrumenting your code, and you should let your monitoring system do as much as it can for you. We had, for example, this customer who was saying, oh, I came up with this very cool idea. I have a big Kubernetes workload and I have a lot of Java applications running inside containers. So I have this little script that runs inside my containers that fetches through a JMX proxy, fetches all the JVM statistics such as garbage collection and heap. Okay, that is horrible. If you're spending your time extracting such basic system metrics, I understand that it's inside a container and so it's not as easy as it will be from if this application was being just in the host. But your monitoring tool should provide you the primitives to clearly cross the container boundaries and extract anything you need in that case. So everything that's related to namespace crossing or things like that should be provided by your monitoring tool. So that gets to the second point. The only thing that you should really care about are essentially your stats metric, right? That's about it. So should be the number of cookies that have been ordered through your online shopping website, things like that. So things that your monitoring tool cannot know by itself. The other item, which is it's really the core, and a lot of talks I've already touched on this in these past couple of days, is that tagging is really important. Every metric should be absolutely tagged. So let me show you what I mean. This is SysDig Monitor. So this is just an infrastructure monitoring tool where I have a workload with several containers over here. And you can see that I have here basic system statistics on them, which again is cool. But you can see how there is some affinity between these containers, right? For example, this WordPress container, there's another one, and then there's another one. So just looking at those metrics, at those individual metrics, doesn't make sense, right? So you need to make sure that each of these metrics is tagged in the right context, which in the case of Kubernetes is, for example, grouping them by the concept of namespace. So now you can see that inside my 2 namespaces, dev and production, I have 2 copies of the WordPress microservice, each one with a replication factor of 3, so I have 3 containers. And my monitoring tool needs to be able to automatically provide me this row, right? So in this case, this is the average. We said that average is bad, so here you can substitute a max, a percentile, anything you want. And this row is what is really important, right? this is really the performance of the microservice as a whole, and your monitoring tool should provide you with enough context so that you can tag things. If things move around, so if this WordPress container dies and gets rescheduled in another host, the monitoring tool should automatically pick it up and put it back in the right context. And then it's a plus if you look at things even from a lower level, such as the one from the system call. So for example, then by clicking on my entire service, I can take a look at pretty granular things, such as the individual HTTP requests that my containers are doing with the response time and things like that. And this happens all because we looked at the actual payload that is going on the I/O system calls. So tagging is really the most important things when you are doing monitoring for containers. And so you should be making sure that tagging is heavily integrated with Kubernetes. So Kubernetes exports for each of your containers, there is a very significant and large context around it. So you should make sure, and each of these things, for example, you have a pod, you have the deployment, you have the namespace. Each of those things have several labels that the operator or the developer can choose, and you should make sure that your monitoring tool correctly correlates those metrics with the proper tags. Because then the other point is, you should absolutely not be involved in tagging metrics manually. We have seen, I'm saying this might seem a little bit trivial, but we have seen a lot of customers who actually were in the code where they were pushing their static metric and they were like, okay, I'm pushing this number of requests in my REST controller, and then I'm gonna append at least this big of tags, which come from Kubernetes. You know how stressful it is to get at the point in the code where you're pushing the metric, get the whole chain of tags that apply to that specific metrics? It's absolutely awful. Like actually in Kubernetes, it's pretty difficult. You would have to use some sort of downwards API or manually propagate things to through environment variables. So your monitoring tool should be able to pick the metadata from one side, pick the static metric from one side, and automatically correlate them, so that then the only thing that you need to do is push your single static metric without any context. And the other one, also obvious from the other talks that we have seen, is that you should collect everything, exactly like you do with logs, that you collect gigabyte of logs per hour, and then you just use grep of Elasticsearch or anything even fancier to just get the information that you wanted to do for your specific context. Same thing is for metrics. You should collect millions and millions of metrics because you never know when they are going to become useful. So we have actually seen tons of troubleshooting use cases where just after an outage, metrics that no one would have thought about in the first place helped solve the mystery. So, okay, and this is enough for making sense of the data. The other item is clearly the troubleshooting one. As I said, I really like doing troubleshooting, and there is a real need in the community for more container-aware troubleshooting, which is partly a state of mind and partly like an implementation problems, because many of the tools that we have around are not yet container-aware. For example, this is a screenshot that I got from an issue on Kubernetes where there was an issue that they were trying to troubleshoot, but they were like, oh, I'm running the BusyBox container image, so I'm not gonna have all the tools that I need to do my job. So you need to make sure that your troubleshooting tools take care of the container identity. So this is what I mean. You've probably seen this demo already at some point, but it's always fun to show. So this is just a Curses UI for sysdig, which is a system call-based troubleshooting tool. And this is showing me a bunch of processes that are running in my system, and all these are containerized. So what happens if I switch to a view that is based on containers? This is now showing me all the containers in my system, as you can see here in the right side of the screen, along with their images and the resources that they are consuming. So, okay, this is already a little bit better, container-based troubleshooting. But something that I can do, for example, let's say that I'm trying to troubleshoot a Redis issue. So I'm filtering for Redis, and I can see that I have exactly 2 containers with Redis. The other 2 ones are just the placeholder that Kubernetes puts to keep a hold on the network namespace. So I have Redis, and if I press enter, I like to drill down and start the troubleshooting inside this specific container. So now it's showing me just the processes running in these containers. And while I'm inside this container, I'm going to switch view, and I'm going to switch to the network connections. And this is showing me in real time a netstat-like view of all the connections that are going on in this container. This is really not trivial. If you try to do this with netstat, you'll have to recognize that you have to manually change namespace. And same thing if you try to capture things with TCP dump, you have to guess the network interface that matches to this network namespace. And since this is a system call-based troubleshooting tool, once I am here inside this connection, I can press F5 and I go into echo mode, where this is actually showing me the payload of that is going on this Redis connection, which is, if you've ever done Redis programming, these are just GET requests for the simple Redis protocol where my application is requesting a counter. So notice how easy it is, and I really think that troubleshooting for containers should be this easy, whatever best practice or troubleshooting tool you have. There is still one thing that I don't like that much, which is here, when I started my troubleshooting, I started from the containers view, but notice how these names are quite messy, right? These names were not chosen by me, these container names were not chosen by me, were not chosen by my application developers, because these were automatically picked by Kubernetes. So when I have to troubleshoot in something quickly, I don't even know which container I should look at. So why we don't bring the concept of tagging also for our system level troubleshooting tools? So instead of starting the exploration from the container name, let's start it from the Kubernetes namespace. So here I can see that on this machine, I have containers running in both the dev and in the production namespace. And then I can select this, and this will show me the pods, which again, the pods are the containers wrapper in Kubernetes. And notice how the names are much nicer, and most importantly, notice the labels here. Now we are talking. This is the set of metadata that as an application developer or infrastructure operator, I explicitly chose. So I can do a troubleshooting, even if it's advanced, I can do a troubleshooting driven by those things. So let's explore, for example, one. I have over here this Java app pod. If I select it, this will show me the container that is running in this pod. And if I select it, it will show me the commands. In this case, I have a Tomcat application, and then I have an nginx reverse proxy in front of this Java application, which probably just does some SSL offloading. But let's see. So let's select the nginx worker process. And while I'm selecting it, let me look at the activity I/O that is doing. And you can see how I can trace each individual HTTP request that this container is doing from outside the container without touching the container itself, which is extremely important for, especially when you're doing live production troubleshooting. And don't let yourself be fooled by the fact that a troubleshooting tool should just work with network data, because you should be able, while you're selecting, for example, this nginx process, to switch to the files in real time. Notice the files that the nginx process is opening, reading, or writing. So this is the files. It's very difficult in Linux to get a metric broken down by individual file. And so you can see that nginx is writing to the access.log, and since we are seeing things that the system calls, I can press F5, and I can look at the individual log entries that nginx is writing as we speak inside the log, all outside. So this helps essentially crossing the container boundaries and making things a bit more user-friendly. So this is what I meant with troubleshooting. The last item I had is about people. So what we have observed is that people are taking the concept of container scheduling and application deploying in containerized environment to create some sort of multi-tenant clusters where several applications and several teams can coexist in a single cluster. So monitoring should also be focused and tailored around those individual teams, even if you're collecting metrics from a single pipe, which could be, the single host. And so what we found out is this. What we try to do is a monitoring tool that from the left ingests all the metrics. Could be static, could be system calls, everything you want. From the right, it extracts the service metadata. So labels for containers, labels for Kubernetes entities. And then it routes these single specific metrics to each individual team depending on their needs. So if team 1 just needs to operate on one specific Kubernetes deployment, even if the cluster contains other 100 different other applications that are owned by other teams, team 1 should just see the metrics for that specific application and should just get the custom set of alerts and dashboards. So we have been experimenting with this, and our customers were happy, but then they said, but still our users screw up a lot because they end up doing a lot of copy and pasting on things for different teams. And this also is linked to a talk that we have seen before where the presenter was saying, let's also make dashboarding and alerting as a code. And so we started saying, can we move this concept of per team monitoring inside the code? And so we did an experiment. So this is the manifest that I used for deploying that Kubernetes service that you were seeing there. So you can see it's a simple Kubernetes deployment where I'm running 3 replicas of a WordPress container over here. This is the template. You can see I'm even putting a password in clear text as an environment variable. Very bad. And then you can see that in the annotations, which is essentially a free section that Kubernetes lets for third-party consumption, I am specifying annotations that are supposed to be parsed by my monitoring tool. So I'm saying, hey, whenever you deploy this application, also create me a team for my monitoring tool where these members will have access to. I want these dashboards pre-made, and I also want my alerts as part of this application deployment. So I want an alert on the response time. I want an alert whenever the response time goes above 500 milliseconds over a 1-minute window. And I also want an alert when every single container has a CPU that goes above 80% over the span of 1 minute. So this concept of monitoring as a code we think is very cool, because then when you deploy this service, your monitoring tool can automatically create the entities that then become immutable. And so you keep the monitoring, dashboarding, and alerting right exactly as you will deploy your application as a code. And so let's see, for example, over here. Here I am in my root team, and this is the team that can see everything. But when I deployed my WordPress, which again, I deployed 2 copies of this, one in the dev and one in the prod, my monitoring tool automatically creates me 2 teams. And in one team, for example, if I switch to the dev, I am just being able to see internet connection. I'm just being able to see the individual 3 WordPress containers that match the context that I specified in my manifest. And we have seen that small and medium companies, which usually don't have the resources, to create these sort of things by themselves, can gain a lot of benefits by having a monitoring tool and a monitoring framework that provides this primitive, that provides not only infrastructure as a code, but also monitoring, dashboarding, and alerting as a code. Because then you can see over here that then you go to dashboard, and yeah, you see all the SQL queries that just that specific application is doing, and also the alerts. You can see the 2 alerts that I configured that are automatically set up, and they are immutable. So if you want to change them, you change them in the code, you commit them in Git, and the dashboard will be automatically updated exactly the same as the alerts. And we think that this concept is quite interesting. It's gained a lot of popularity. And again, the use cases are several. The use cases are around everything that revolves multiple teams deploying their application on a single cluster, which again, the majority of our customers who have containerized workload do. They really like to pack things really like crazy, having hosts with dozens, if not even more, hundreds of containers. And yeah, this is essentially all I had. If you want to check more pointers around this concept, we have a few blog posts where we described a little bit more in details how this concept of monitoring as a code works. And that being said, thank you very much. Thanks.
Hello, everybody. Still a good crowd. Let's see, running out of space. We made it.
Are there any conference organizers here?
Well, this is going to be a minute-for-minute delay on the hike leaving. You rehearsed this? No? Can anybody guess what those numbers are?
But it's mirroring, so it's not showing.
Display preferences and then arrangement.
Oh, thanks. Oh, it's because I'm mirroring it. Sorry. I had that, right?
You were the one who got that? Who made the suggestion?
Bill. Thanks, Bill.
Thanks, Bill. Oh, there you are. Thanks, Bill. Round of applause for Bill.
Thanks, Bill. All right. We're going to run through these really quickly. Again, thank you to everybody that participated. Thank you to all of our organizers and volunteers, specifically to Will, Molly, Danielle, Ryan, Brad, and Jordan, to Pete, who helped me with the book signing again, to the video team from Searle Video, to the internet and Wi-Fi team at FreeWire, and to the immensely professional and highly skilled staff at Portland Center Stage. To our sponsors who continue to support us year after year, and to our speakers who provide us with consistently excellent content every year. And last but not least, certainly, to all of our attendees who make Monitorama a pleasure to create every year. If you don't mind, please give yourself a round of applause. I really appreciate it. So this is, well, I don't know if I should say tradition because I'm just reusing a lot of the slide deck every year, but this is the third year we've done this. I like to kind of share some of the numbers and statistics behind organizing an event. So to date, the number of Monitorama events we've held, the number of Monitorama events that have been held in Portland, the number of attendees last year, the number of attendees this year, the maximum number of seats in this theater, the number of folks on last year's waiting list, the number of folks on this year's waiting list, the number of angel tickets sold for charity, the number of graphite books sold for charity, the number of dollars donated to charity, not this charity, number of members in the Slack team last year, number of members in the Slack team this year. It is, you know, we add to it. Number of participants for our Sunday Fun Day hike, length in miles of the Sunday Fun Day hike, average number of ice cream cones consumed per person on the Sunday Fun Day hike. And you can guess who skewed that number. Number of full-length talks given this week, percentage of women speakers last year, percentage of women speakers this year. Last year's goal for percentage of women speakers this year. This year's goal for percentage of women speakers next year. Number of Blue Star donuts served this morning. Number of Blue Star donuts consumed by me this morning. Peak megabits per second of internet bandwidth this week. Peak number of wireless clients this week. Yeah. Oh, and in case you hadn't heard, when we were having that DHCP wireless allocation issue on the first day, it's because you all crashed the DHCP service on the Juniper firewall. And they'd never actually seen that before. Peak number of concurrent live video stream viewers this week. Total number of live stream visitors this week. Number of assistant organizers who make it possible to keep this show running year after year. Where are you, Will? Come on. Why don't you get out there? One more, come on. Thanks, buddy. Number of underground fires in downtown Portland this week. Number of... Statistically. Number of conference days lost due to underground fires this week. And yet, dollars spent on alternate venues due to underground fires this week. Number of fucks given over underground fires this week. And that's it. Thank you very much. It continues to be an honor and a privilege to bring this event to you, and I hope to see you again soon. Thank you very much.